Have you ever found yourself mesmerized by the seamless operations of your computer, marveling at how each component works in harmony to deliver the digital world to your fingertips? Do you want to learn more about this fascinating topic? In this course, you'll embark on a journey through the fundamentals of computer systems. Whether you're an aspiring IT professional or simply curious about how technology works, this course will provide you with the foundational knowledge you need. You'll start this course by being exposed to the security threats that computer users have to deal with, and then examine the inner workings of a computer system, identifying key components like the CPU, memory, storage devices, peripherals, and other vital hardware elements. Once you've established a solid understanding of hardware, you will explore how these components interact with the operating system. You'll dive into the inner workings of CPU processes and memory management. Additionally, you will examine the crucial role of device drivers. Finally, you will focus on the broader relationship between hardware and software. You'll learn about the essential concepts that underpin this relationship, such as abstraction layers, instruction sets, and system architectures. By gaining a grasp of these concepts, you will acquire insight into how hardware capabilities shape software design and vice versa, ultimately fostering a holistic understanding of system functionality. After completing this course, you will be able to identify the key components of a computer system encompassing a variety of hardware elements, describe the interaction between computer system components and the operating system, including how the CPU processes instructions, memory management, and the role of device drivers. You will also be able to discuss the essential concepts that define the relationship between security, hardware, and software. This course is designed and built by subject matter and industry experts in the field. You can be confident that this course provides the perfect starting point for your future career as an IT professional. The knowledge you gain from this course also helps to prepare you for the MS 900 Microsoft 365 Fundamentals exam, serving as a valuable step forward in your career. A support role in information technology, or as it's often called, IT, includes handling computer systems, networks, and software applications, showcasing expertise in areas like cybersecurity and networking configuration. Throughout your learning, you'll be able to build the skills that you need and apply your knowledge through a variety of activities and real-world examples. By completing this course, you'll establish a foundation for a deeper understanding of computers, operating systems, and associated security threats. This will allow you to satisfy your curiosity about the digital world and at the same time build a successful career in information technology. Good luck as you start this exciting learning journey. Well done on completing Introduction to Computers and Operating Systems. Before you continue, let's recap on some key takeaways. After familiarizing yourself with the course learning objectives, you began with an introduction to the threat landscape. Here you learned about how cyber attacks occur. You can now describe current cyber attack statistics and trends and explain how unauthorized access gained has a huge impact on multiple devices or domains. You discovered that the threat landscape is broken up into three distinct areas: the vulnerabilities of the application, the types of attacks used, and the perpetuators of the crime. Next, you were introduced to computing devices and discussed the basic components that make a computing device. Whether it is a laptop, desktop, or mobile device, it requires some basic components. Let's recap on 4 of these components. The first component is the central processing unit, or CPU. It is often referred to as the brain of the computer, where the computation is performed. The second component is RAM. RAM is a plug-and-play addition to a computer that stores information. Can you imagine if you had to relearn every task when you woke up every morning? RAM ensures that a computer can recall, and recollection is a core requirement for intelligence. You then learned about input and output devices. This is crucial to a computer because it takes in the input, decodes and processes the data, and displays an output. The final component is the motherboard, which enables the operation. It does not actively take part in computation, but it provides a hub through which all these components interact and generate the desired output. Then you learned about computer graphics and discovered how visuals come to life in computer systems. You now understand how graphic cards process and render visual data and how it is displayed. Additionally, you explored how complex processes enable the visual displays on computer screens. You broadened your understanding of computers by unpacking the differences between hardware and software. Remember that hardware makes the physical device operate and software gives instructions so that the hardware knows what to do and how to do it. It's an interdependent relationship that allows you to interact with your computer. Finally, you focused on operating systems, which provide the directions that are sent to the hardware. They configure applications so that they communicate efficiently with hardware devices. You examined several major operating systems, including those specific to computers and to mobile devices. Then you explored the two main categories that the software generally falls into, which are proprietary or open source. You should now be better informed about how to choose a suitable operating system for a specific business need. Recall the three key responsibilities of an operating system. It controls the access of hardware that is connected to the device, physically or digitally. It provides the interface that enables you, the user, to communicate with the computer's hardware and software. Specifically, the interface is a command line interface or a graphical user interface. And it manages files and applications by allocating suitable system resources as determined by an API. Next, you explored the various types of software found in computing environments. Remember, each type serves a distinct purpose in a computer system. System software manages computer resources. Application software carries out specific tasks for users. And utility software maintains efficient software operations. Having completed the Introduction to Computers course, you have an excellent foundation to navigate the world of computers. You are well versed in computer basics like hardware, software, and operating systems, and gained insight into the various threats facing the IT industry today. Nice work. Congratulations on nearing the completion of this course. Your dedication to completing videos, readings, quizzes, and exercises has provided you with a solid understanding of key concepts in computer systems and security threats, such as major types of cyber attacks and how they happen, the basics of computers, operating systems, and software, solutions for setting up enterprise systems and maintaining security, and the common software and tools that businesses use to enhance productivity. That means you're now ready to apply your knowledge in the final exercise and course assessment. This is a graded quiz that consists of 30 questions that are related to topics covered throughout the course. But before you jump in, let's recap what you've learned up until now. You began your journey by gaining a foundational understanding of computer systems, focusing on the intricate relationship between hardware and software. You then explored the current threat landscape that is affecting the computer world and explored some of the challenges faced by computer support specialists. You also examined several key hardware components, operating systems, and software types, including their development and functionality, before covering essential concepts such as memory management, system updates, and network communication. This section equipped you with the knowledge needed to understand and interact effectively with computer technology. You then focused on understanding computer setups that can meet the demands of businesses. You explored how servers, storage, and backup solutions are used together as a system failsafe. This practice ensures that a duplicate of important data is available in case the original is lost or damaged. You then compared different types of computing environments. You found that there is a distinction between simple personal computing setups intended for individual users and more powerful commercial computing setups for business use. Furthermore, a business must choose between having its computing infrastructure on premises, which allows for greater control of data at the cost of less flexibility, or operating out of the cloud, which is typically more cost-effective. You also received an introduction to security strategies for both on-premises and cloud computing environments. You learned that while implementation differs for each approach, both are guided by the same principles. You concluded with an overview of maintenance and patching, which are practiced for keeping software running smoothly and securely. You should now know that because these tasks typically involve system downtime, businesses will try to perform them in the least disruptive manner possible. You then explored a range of techniques and best practices for optimizing a computer's performance, discussing various topics including disk cleanup, defragmentation, memory upgrades, and settings adjustments that can improve the efficiency and speed of a computer. Following this, your focus shifted to business software and solutions used by companies to meet various needs, from automating invoices to analyzing customer data for insights. Common Microsoft applications like Word, Excel, and PowerPoint were highlighted, along with tailored packages such as Microsoft Dynamics 365 for customer relationship management. You then examine the challenges posed by software and hardware limitations on computer systems, including resource-heavy applications and compatibility issues, offering strategies like optimizing settings and leveraging cloud computing to overcome these limitations. Cloud services were discussed as a solution to hardware constraints, providing scalable resources through models like IaaS, PaaS, and SaaS. You also explored the basics of email, including its history, impact on communication, protocols, popular clients, and spam management. The importance of customer data for businesses was emphasized, detailing storage in data lakes or warehouses for analysis with machine learning models to drive informed decision-making. Through your commitment to engaging with videos, readings, quizzes, and exercises, you have gained a comprehensive understanding of fundamental concepts in computer systems. You have explored the basics of computers, operating systems and software, enterprise system setups, security maintenance solutions, and common business software tools. As you prepare for the final exercise and assessment, take a moment to reflect on your journey. You have equipped yourself with knowledge essential for interacting effectively with computer technology and are now ready to apply your learning in the assessment. Best of luck. When you work on any document, are you aware of how often you press the save button? Perhaps you are quite diligent and make an effort to save your work on your local machine regularly. Sam, the owner of Sam's Scoops, is still experiencing a massive demand for ice cream in the community. Business is booming and she is so thrilled. The team's hard work is paying off. However, this rapid progress in business sales also presents the challenge of more administrative tasks. She diligently saves her inventory documents often. Despite her efforts, an unexpected problem has caused the main computer to stop working, resulting in it being sent off for repairs. Sam's Scoops didn't account for this hurdle, and stress levels are high with the pressure of keeping up with the local demand. The repair technician confirmed after assessing the main computer that recent data cannot be recovered, but has proposed a backup solution at an additional cost to avoid this happening again. This situation has caused time delays and additional expenses to fully restore operations for Sam's Scoops. Previously, you learned about some basic backup solutions. This time, you'll go deeper and discover some approaches that would have helped Sam's Scoops. In this video, you'll learn about a concrete 4-step plan that ensures the safety of your data in the event of potential issues occurring in your day-to-day business. You'll also start to identify suitable backup solutions for specific business needs. When it comes to recovery, you are only as good as your last backup. Sam from Sam's Scoops is working on a project using Microsoft Word. Sam checks the autosave feature when working on Word, minimizing information loss due to unexpected shutdowns. Suddenly, the battery unexpectedly quits. How much data is safely stored? Only the information written before the last save is still there. Saving the information is a form of defense against an unexpected program shutting down. However, if the issue is that the laptop is lost or damaged, saving the data may not be enough. In this instance, Sam ideally should have used an external hard drive, USB stick, or some form of online storage such as cloud storage. Only then would the information relating to the daily activities of Sam's Scoops be safely backed up. Physically separating a backup from the original file makes the most security sense. Consider the scenario where a computer storing your information is physically damaged. With a backup, the information is recoverable. Think back to a database server solution. Using a database server to keep your company's information ensures that the information isn't lost if something happens to your primary storage. The best practice is storing backup data off-site, giving you excellent protection so that you have an alternative way of accessing it. Practicing the following 4 steps protects your data from unexpected shutdowns, technological failure, and malicious cyber activity. Let's begin with step 1, replication. This concerns copying data from one location to another. It's like the autosave function in Microsoft Word that keeps recoverable, near real-time copies of your information. Step 2 is snapshots. A data snapshot is a regular save point throughout the day. It's good to implement a policy to schedule automatic saving of all your business information. The third step involves daily backups. In addition to regular snapshots, it's beneficial to store your information in a second location that is not on your premises. Therefore, saving to the cloud means that any incidents your business potentially suffers stops at cloud storage. Here, additional safety checks are also carried out. The final step is what is known as the 3-2-1 backup strategy. The 3-2-1 backup strategy is regarded as the most effective backup route and relates to creating your backups. If the information is particularly important, why not create 3 snapshots of the data? This is exactly what the 3-2-1 strategy is. Use 2 different formats, such as locally on your computer where you create the information, as well as on your data server. Ideally, one of these copies is kept off-site. This way, the essential information used to run your business is always protected. It's important to note that different data have different levels of importance, so implementing the 3-2-1 backup strategy may be considered excessive. However, many recent cyber attack strategies include removing the legitimate owner's ability to access their data instead of deleting it altogether. You may face technical obstacles when deciding on the appropriate backup approach. This is often daunting. The good news is that throughout this course, you'll witness several implementations and strategies that you can use in your business. It's also worth noting that when you deal with other people's information, there is an element of trust. The customers of Sam Scoops trust that the necessary due diligence is carried out to protect their data and provide a timely service. Think of it as an unspoken service level rule between customers and service providers. In this video, you learned that protecting data is a significant commitment that any business owner commits to. Additionally, you unpacked backup solutions that regularly save data, ensuring it is safe with a quick recovery feature. These backup solutions allow you to assess your backup needs and implement the appropriate solution. You also learned 4 practical steps that protect you against unexpected device shutdowns, technological failure, and malicious cyber activity. Imagine that you have decided to take steps to improve the security of your home. What options do you have available? You could reinforce the locks or install a gate. Perhaps you could set up a camera system to monitor your property. So which is the best choice? Well, before deciding on a solution, you first need to consider the threats that you are most likely to face. Similarly, cybersecurity threats exist in many forms, and the first step toward implementing effective safeguards is to better understand the types of threats that are out there. In this video, you will become familiar with the threat landscape, what it is, and how it can potentially affect you. You'll be introduced to several concepts that will be explored in greater depth later on. On completion of this video, you should have a high-level understanding of the threat landscape and how it has changed over time. You'll also be able to describe the manner and environment in which cyber attacks take place. To illustrate the importance of these concepts, let's examine them from the perspective of the local ice cream shop, Sam Scoops. With a recent surge in popularity, the shop is struggling to keep up with phone and email orders. Sam has been advised to use business software to manage these tasks, but she knows little about the options available. She is also wary of taking any operations online because of security issues associated with the threat landscape. Let's first break down what is meant by threat landscape. This is an all-encompassing term that refers to 3 major areas, which are all potential vulnerabilities of an application, the attackers that may be targeting this area, and the attacks that are used. Traditionally, threats to a business include intruders accessing a physical location and removing items of value. But as you may know, a large volume of business these days takes place online. With this trend, new threats and attacks begin to manifest. The resources being guarded become less distinct as companies had to care for physical damage or theft as well as guarding information and access to a company's digital infrastructure. During this transition, there was a clear distinction between intranet, which is the internal communications of a company, and internet, or the worldwide connected web. Companies and individuals would typically set a firewall to guard important internal resources. A firewall can be defined as a block or filter that prevents some external items from entering a system. This firewall was placed at the gate of a company's digital infrastructure and, much like a security guard, prevents any potentially harmful elements from entering. Threats of note would include malware, which is software intended to cause harm or discord; ransomware, which prevents an organization from accessing its own applications; denial of service, which bombards a system with requests so that it cannot respond to legitimate digital requests; and spam-related activities. These attacks are typically clicked or triggered and access a company's internal system. To prevent this, a firewall limits the content that is allowed to enter. However, the threat landscape has further evolved as an increasing number of individuals work from home. This added to the complexity of defending a system due to the need to increase the level of external access that is required for remote work. The proliferation of remote access tools which allow workers to access an organization's network content from outside, and the practice of bring your own devices, has drastically expanded the threat landscape, reducing the efficacy of firewalls and giving potential attackers far more scope for infiltration. Much like the security guard mentioned earlier, firewalls typically relied on there being a limited number of entry points. Defensive strategies have evolved to identify past attack patterns and develop solutions based on them. However, cyber criminals have evolved with these approaches to continue gaining illicit access. Some modern approaches don't even require a direct vulnerability to exploit, but instead attempt to harvest personal data on an individual. This stolen data is then used to spoof or imitate their identity and then gain access through legitimate channels. You've observed that the nature of accessing network changes regularly, which means that potential attackers look for new vulnerabilities to exploit, and new security strategies must be developed as a result. In this video, you have learned about the threat landscape and how it has evolved over time. This includes being aware of how defensive and offensive actors are constantly competing with one another to construct and deconstruct security initiatives designed to secure digital applications. Congratulations on finishing Enterprise Systems and Security. During this time, you've been introduced to many new concepts relating to the use of commercial computing setups and how to keep them operating safely. Before you move on, let's briefly recap the most important points that were covered. You first explored the ideas of servers, storage, and backups, and how these are utilized to minimize the risk of data loss. You learned that these concepts together form a system failsafe for enterprise setups. To be more specific, the servers move and store data on the network, while storage is used to hold duplicates of that data that come into play if the original data is lost or damaged, or when internet connection issues prevent communication with the servers. You discovered that as a general concept, servers are a component in the client-server model, in which a client sends a request for a service and the server responds by providing that service. Common types of servers include web servers that host web pages, database servers that store information, and print servers that handle requests sent to a printer. These various roles demonstrate why it is critical for a business to keep their servers running. When it comes to storage, you learned about several key considerations for choosing a suitable solution. These include durability, or the length of time that the storage is needed; scalability, which concerns the solution's ability to adjust as the business's data needs grow; availability, or how readily accessible the data is; and security, which relates to how safe your data is against unwanted access. You found that backing up data is a practice that takes planning and maintenance. Depending on the nature of the business, you'll need to decide on factors such as the storage format to use and the extent of data to backup. Fortunately, you are made aware of a 4-step plan that applies to many situations. This plan involves replicating data, taking regular snapshots, performing daily backups to off-premises locations, and following a 3-2-1 backup strategy. Next, you learned how to distinguish between different types of computing environments. You discovered that personal computing relates to individual users at home who generally don't require powerful components, while commercial computing typically needs more memory and processing power to handle larger scale tasks. Commercial computing was also further divided into a traditional on-premises approach in which all computing infrastructure is contained in the same location, or a cloud-based approach that moves most of these components online. You are made aware that the security strategies for both approaches adhere to the same principles. of preventing unauthorized entry, limiting mobility within the system, and mitigating any negative impact resulting from a breach. However, you also found that the methods for implementing these strategies differ due to the distinct ways in which access is handled within each approach. For example, you found that the concept of a firewall applies differently for cloud environments than it does for on-premises environments. Whereas an on-premises firewall only needs to monitor external traffic that tries to enter the system, the distinctions are less clear in a cloud setup in which many system resources may be outside of the system. You also learned how to use the device manager to identify components and understand their roles within a computer system. Finally, you were introduced to the practice of patching, which applies updates to software for the purpose of adding or improving functionality, enhancing security, or getting rid of bugs. You learned that because this maintenance is typically performed on software that is in use, it needs to be done carefully to minimize impact on the operations of a business. You discovered several approaches for accomplishing this, including corrective maintenance that deals with bugs or vulnerabilities before they become a problem, routine maintenance that manages applications on a regular schedule to keep them up to date, and predictive maintenance that takes action based on signs of impending issues. You then explored various techniques, including disk cleanups, defragmentations, memory upgrades, and settings adjustments that can improve the efficiency and speed of a computer. Going a bit deeper, you also found that detection of vulnerabilities happens through several types of testing, such as network testing to identify if open ports can be accessed by unwanted elements, penetration testing to determine the strength of a system's security, and vulnerability verification to assign scores that correlate with the level of risk. By completing enterprise systems and security, you should now have a stronger awareness of the many points for consideration when it comes to protecting a business computing environment and the data that it holds. More importantly, you understand the guiding principles of strong security and know several best practices you can implement to minimize risk. Well done. Sam, the owner of Sam Scoops, is currently operating her business from a single homebound personal laptop. The demand for local ice cream is continuously growing within the community. There is an expansion plan for Sam Scoops that includes opening a storefront to meet the growing demand. Sam realizes that getting more hands on board to meet the demands of her growing customer base means that more computer devices with adequate security measures are needed soon. With Sam's desire to grow the brand's footprint and expand the team, she needs to have a basic understanding of the hardware and software requirements for Sam Scoops to operate efficiently. This allows Sam to advise the team on using the technological infrastructure to create future product developments. In addition, Sam can implement the appropriate security measures to protect Sam Scoops' employees and her customers. Let's join Sam on her journey to learn about computer basics so that she'll be able to make more informed decisions about the right tools for her business. This video summarizes what a computer is and what it consists of. You'll gain more clarity as to what happens when inputted data is entered into a computer and the various transformations it undergoes before it displays on the screen. Knowing how a computer works will set the stage for the hardware and software concepts that you'll learn about later. So, to start, let's think about the components required to take in user input and display it on screen. A computer must perform the following 4 tasks, which are inputting, storing, processing, and outputting information. Let's begin by discussing input. Taking input can be done through a host of devices. Consider how you access this course today. Did you do it from a laptop, phone, or personal computer? Devices used also include cameras, microphones, keyboards, and computer mice. Depending on the device, once the signal begins, a conversion happens between the input and the storage it is sent to. Consider what happens when you push a key on your keyboard. The key triggers a series of zeros and ones and transports it to the storage unit of your device. Devices communicate with software by means of a device driver. So, what is stored after receiving the input? When a computer receives an input, it immediately stores the information in memory. There are different types of memory available, but generally it can be classified as volatile or non-volatile. Volatile memory, such as RAM, is temporary and saves data only while the computer is used. Items that are stored in RAM are not permanent and are sustained as long as the RAM receives power. This means that if the power is cut, then the items are lost. Non-volatile memory is permanent, and data is stored whether the computer is on or off. Typically, computers will come with some secondary memory built in for additional storage to hold items permanently. Additional memory is stored in hard drives, commonly referred to as secondary drives. It is categorized as non-volatile memory. Alternatively, you can make use of external hard drives or USB drives. So, once the input data is stored, it needs to be processed. Let's explore the processing aspect. All processing on a computer is done by the CPU. The CPU has two parts, which are the control unit and the arithmetic or logic unit. A CPU has a small memory component called a register, but mostly reads information from the secondary memory. It then performs the required operation and stores the result back into the memory. To help you understand this process, think of a CPU like a human brain. The control unit receives a signal. Whereas a computer takes input from a mouse or keyboard, the brain does so through senses like sight or touch. The arithmetic unit contains logic for how to handle the input, like the reasoning part of the brain that holds math formulas you learned in school. Registers are like short-term memory, while secondary storage is closer to long-term memory that may take more time to recall. The CPU is the computer's brain, where all the calculations and processes run. A control unit will receive an instruction, decode this instruction, and then issue signals based on the results of the decoding. CPUs follow a cycle which includes 3 steps. The first step is fetch. Here, data is collected from memory. The second step, decode, is where the data is interpreted. Finally, in the execute step, an action is performed based on the instructions provided. Memory on a bus retrieves the information. A bus is a set of physical components that connects and transfers data from the memory to the CPU. Next, the information is returned to where it is stored on the computer. Once the data has been processed, the memory bus returns the information for storage. Notice that information is loaded constantly from and to memory. This accounts for much of the time used for executing a program. So, the last step to processing information that is displayed on your computer is the output. The output reflects the final transaction in the process. Once the input has been received by the device and the appropriate process applied to it by the CPU, it generates an output. This might be performing an action, streaming a video, or executing a program. Depending on the device and its use, the output manifests differently. It usually takes the form of an image or a light, showing that a process successfully executed. An example of this is a toll booth. A green light indicates that your payment is accepted. To summarize, a computer goes through 4 basic steps. Information is taken in through an input where the signal is stored in short-term memory before being processed by the CPU. Much like how the human brain works, the CPU performs a series of actions that pulls items from memory. Then it performs some computation and returns a result. The final step is the output. For humans, this might be verbalizing the thought that has been processed. For a computer, it could be displaying a text message. In this video, you learned what a computer is and what it consists of. You have a better understanding of what happens when inputted data is entered into a computer and the various transformations it undergoes before it displays on screen. Right now, you're using a computer, tablet, or smartphone to navigate through this course. Despite these devices being different, they function in the same way, in that you can input data, the data is stored, and then processed to produce an output. A computer connects you to the digital world. You use it to enjoy entertainment, interact socially via social media platforms, or work efficiently from anywhere in a paperless environment. So, what makes up a computer? A computer consists of 2 overarching parts, the hardware and the software. The hardware relates to the physical devices that make up a computer. It is the part that the software runs on. Software gives the hardware instructions on what to do and how to do it. The desirable components for a gamer's personal computer, PC, differ from those found on a college laptop or within a tablet or phone. But fundamentally, there are a few key components that are involved. In this video, you'll unpack essential hardware components that make up a computer. The motherboard is the hub in the form of a circuit board with slots for the components required to make up a computer. When dealing with Apple devices, it is referred to as a logic board. Following on from the motherboard, a predominant item required in creating a computer is the central processing unit, more commonly referred to as the CPU. The capacity of a CPU is measured by its clock speed, or how fast it can run. The unit of measurement is called a gigahertz. CPUs are typically found on integrated circuit microprocessors that contain one or more CPUs. You may hear the expression multi-core processors. That means several CPUs are present. These can be configured to tackle a job in tandem. The microprocessor attaches to the motherboard and functions as the computer's reasoning center. Modern phones would typically run on quad cores. Quad here is a reference to 4, meaning there are 4 CPUs used for processing content. CPUs have limited scope for holding memory, so this is stored in the RAM, which stands for Random Access Memory. The RAM specs are important when purchasing a computer because they relate to how large a task the computer can process at one time. Think of RAM in the same way as a human's short-term memory. How many well-informed decisions can you make without referencing additional information externally, such as using a book for research, which takes time? The more information you mentally retain at any time, the greater your ability to recall information instantaneously. Therefore, the larger the RAM, the quicker and more powerful a computer is. Typically, the minimum RAM size of a small desktop or PC starts at 8 GB and increases in increments of 8. 16 GB of RAM achieves most standard operations. However, high-end gamers opt for up to 64 GB of RAM. A tablet would typically have between 2 and 16 GB of RAM. The motherboard will have unique slots where RAM fits in. It is also possible to upgrade computers by buying more RAM and manually plugging it into your motherboard. If RAM is associated with short-term memory, then long-term memory can be related to hard drives. These are additional memory sources that hold more information. Hard drives come in many forms, the 2 most common types being hard disk drives and solid-state drives. You'll commonly find these names shortened to HDD and SSD. Hard drives allow permanent storing of information and are attached to the motherboard with adapters called Serial Advanced Technology Attachment Cables, otherwise known as SATA cables. A flash drive is an example of an SSD, meaning it has quicker lookup speeds. HDD is considered an older technology. The final crucial element required to make a computer function is the power source. Large computers will require more power than mobile devices. One might need 500 to 1,000 watts of power to run a computer. This dwarfs the power consumption of a mobile phone. It typically only requires 2 to 6 watts of power. In this video, you learned about the essential components that create a computer, with reference to smartphones and tablets. Some of the fundamental components discussed include the motherboard, CPU, RAM, long-term memory storage, and the power supply. You'll expand upon these concepts and learn about how software interacts with them a bit later.
Generative AI is transforming businesses today by gathering information and creating all kinds of content, changing how businesses operate. Let's imagine a renowned restaurant called Chef's Table. As Chef Andre strives to innovate and delight his patrons with new dishes, he turns to generative AI to enhance his culinary creations. The technology behind this ability involves using models trained on huge sets of data to do tasks such as text generation, image creation, and even code synthesis. In Chef Andre's kitchen, generative AI acts as his trusty sous chef, assisting him in developing innovative recipes, crafting visually stunning presentations, and even optimizing kitchen workflows. Just like Chef Andre relies on his sous chef to complement his skills and creativity, generative AI complements businesses by providing them with new insights, ideas, and efficiencies. In this video, you'll explore the technical foundations and potential applications of generative AI in businesses like Chef's Table. You'll also assess its limitations and examine the ethical considerations that arise when using it. First, let's gain some insight into the technical foundations of generative AI. It operates primarily through 2 types of models: generative adversarial networks or GANs and transformer-based models. GANs involve 2 neural networks, the generator and the discriminator, working in tandem to produce highly realistic outputs. These 2 components are known as the generator and the discriminator. Imagine the generator as a chef preparing a new dish and the discriminator as a food critic tasting it. The chef, the generator, creates new dishes, while the food critic, the discriminator, evaluates them. If the critic cannot distinguish between the chef's creations and dishes from renowned restaurants, then the chef has succeeded. This collaborative process results in the creation of highly realistic and refined outputs. Transformers used by models like Generative Pre-trained Transformer or GPT and bidirectional encoder representations from transformers or BERT use attention mechanisms to create text that is contextually relevant and stylistically coherent. Attention mechanisms play a crucial role in the model's functionality. These mechanisms enable the model to focus selectively on various parts of the input data, much like a chef carefully chooses the best ingredients for a dish. This selective focus allows the model to highlight important information and maintain a clear grasp of the context. Imagine a chef who not only selects fresh ingredients, but also keeps the recipe and cooking techniques in mind to craft a delicious and well-balanced meal. Similarly, attention mechanisms ensure that the text generated by the model is coherent and contextually appropriate rather than a random assortment of words. These technologies rely on deep learning, needing a lot of computer power and data to train them. How well a generative AI model works depends on the quality and variety of its training data, which affects its ability to generalize new information without upholding biases. So you've learned about the technical foundations of generative AI, but what are its practical applications in various business functions? In marketing and customer engagement, generative AI can craft personalized content at scale, from email marketing campaigns to dynamic web content. Think of this as a chef preparing a personalized menu for each diner based on their preferences, creating unique and delightful dining experiences. AI models can enhance engagement and conversion rates by analyzing existing customer data and tailor messages that resonate on an individual level. Additionally, generative AI assists in optimizing operational efficiencies and logistics. For instance, AI can forecast demand trends, simulate supply chain scenarios, and recommend adjustments. This is like a chef estimating the number of diners, planning the menu, and ordering ingredients to minimize waste and make customers happy. This predictive capability enables chefs' table to make informed decisions, reduce costs, and improve service delivery. In the area of human resources, AI-driven analysis of job descriptions and applicant data helps streamline the recruitment process. By generating and evaluating diverse job descriptions, AI can attract a wide range of candidates, potentially reducing biases often found in manual processes. Additionally, generative AI can simulate training scenarios, providing personalized learning experiences for employees. Think of this as a chef conducting cooking classes tailored to the skill levels and learning styles of each student, ensuring everyone learns effectively. Another application of generative AI is document management and technical writing. It can analyze extensive datasets of documents to learn and replicate the necessary formatting, style, and technical language specific to different business sectors. For example, AI models trained on legal documents can help to draft contracts that comply with current laws and regulations. Furthermore, models trained on medical texts can help in preparing accurate clinical trial reports. The technology's ability to understand and generate technical content is like Chef Andre mastering the preparation of complex dishes, ensuring consistency and high standards without extensive manual effort. One of the standout features of generative AI is its capacity to mimic specific writing styles. This capability is particularly useful in marketing and customer communications, where maintaining a consistent brand voice is crucial. By training on a company's historical communication data, AI can generate content that aligns with the brand's tone, style, and audience engagement strategies. Additionally, it can adapt to different styles as needed, much like a versatile chef who can cook various cuisines to cater to diverse tastes and cultural preferences. Finally, the ability of generative AI to produce coherent and contextually relevant text has wide-ranging application in business. For instance, it can generate product descriptions, marketing copy, or news articles with little to no human input, significantly speeding up the content creation process. Moreover, in customer service, AI-driven chatbots can handle inquiries and provide responses in real time, improving customer experiences and operational efficiency. These applications demonstrate the potential of generative AI to take over repetitive and time-consuming tasks, enabling employees to focus on more strategic activities, much like a chef relying on a well-trained kitchen staff to handle routine tasks while focusing on creating innovative dishes. Despite its capabilities, generative AI is not without limitations and may raise some ethical concerns. The quality of output can vary significantly depending on the model's training. Inaccuracies can emerge, especially when the AI encounters data or requests outside its training scope. Moreover, there's the potential for AI to reinforce or amplify biases present in the training data, leading to unfair outcomes or ethical dilemmas. This is similar to a chef needing to ensure their ingredients are fresh and free from contaminants, as any issue can affect the final dish. Ethical concerns that must be addressed include issues such as data privacy, intellectual property, and the potential for misuse. Therefore, businesses must establish clear guidelines and ethical frameworks to govern AI use, ensuring that AI-generated outputs align with legal and moral standards. Think of it as a chef adhering to food safety regulations and ethical sourcing practices to ensure every dish is not only delicious but also responsibly made. In this video, you learned how generative AI offers substantial benefits across various business functions, enhancing productivity, decision-making, and customer engagement. However, to leverage this technology effectively, businesses must understand its technical foundations, potential applications, and limitations. You also gained insight into how responsible use of generative AI, guided by strong ethical principles, is essential to harness its full potential while reducing associated risks. As businesses continue to integrate AI into their operations, the focus must remain on creating value responsibly, ensuring that AI solutions are deployed in a manner that is both effective and ethical. Like a master chef, businesses must blend innovation with responsibility to create a successful and sustainable future. Picture a future where machines not only grasp our language, but also craft it with remarkable finesse, where creativity knows no bounds as artificial minds effortlessly generate images and ideas. This isn't the stuff of sci-fi dreams. It's the emergence of generative AI, a tool that will complement and benefit us in both our work and our everyday lives. To gain a better understanding of generative AI, it is crucial to dive into its foundational technologies, such as machine learning models and their architectural nuances. Let's get started by exploring the distinguishing features of generative AI. Unlike traditional AI, which typically focuses on analysis and classification, generative AI is proactive in creating new content. This shift from passive analysis to active creation is transformative, especially in handling complex tasks such as natural language processing or NLP and synthetic image generation. NLP enables machines to read, understand, and generate human language, while synthetic image generation involves creating fake images using computer programs and algorithms. It's like a digital artist creating a convincing picture of a landscape they've never seen before. The introduction of transformers, a type of model architecture that relies on mechanisms called attention and self-attention, has revolutionized NLP. Models like Google's bidirectional encoder representations from transformers, or BERT, and OpenAI's GPT series use these transformers. They learn the relationships between words in a text, but not in the usual order from start to end. Instead, they can understand different parts of the text at the same time. It's like reading a mystery novel and being able to pick up on clues scattered throughout the book all at once. This way of learning allows for more things to be processed at the same time, making the training quicker and more efficient. So those are some of the distinguishing features, but what are the technical foundations of generative AI? It primarily operates through two types of machine learning: supervised and unsupervised. In supervised learning, models are trained on labeled datasets, allowing them to learn a function that can map input data to desired outputs. For example, a model might be trained to generate text summaries by learning from a dataset of articles paired with their respective summaries. Unsupervised learning, on the other hand, involves training models on data without explicit labels. Here, the aim is for the models to discover inherent patterns and relationships in the data. This approach is particularly beneficial for generative AI, as it allows the model to learn to create content that is not bound by predefined labels, enabling more innovative and adaptive applications. Next, let's take a closer look at some of the core technologies behind generative AI. At the heart of its capabilities are neural networks, particularly generative adversarial networks or GANs, and variational autoencoders or VAEs. Variational autoencoders or VAEs encode input data into a compressed representation and then decode it back to reconstruct the input. The process involves optimizing the parameters of the encoder and decoder so that the output closely matches the input, allowing the model to generate new data samples from learned representations. Language models are constantly evolving, so it's important to keep up to date with these advancements. Language models such as GPT-3 and BERT demonstrate significant advancements in generative AI. These models use transformer architectures, which rely on self-attention mechanisms to process sequences of data, like sentences, in ways that consider the context provided by other parts of the sequence. This is crucial for generating coherent and contextually appropriate text. Word2Vec, another critical technology, involves vectorizing words into a geometric space where words with similar meanings are located close to each other. This enables more nuanced understanding and generation of text based on semantic similarities rather than just syntactic rules. Generative AI has many business applications and can revolutionize several key areas. Let's explore some in more detail. Firstly, there's content generation. GPT models excel in generating written content by leveraging transformer architecture, which allows them to understand context and generate coherent and contextually appropriate text. These models are pre-trained on a wide variety of internet text and fine-tuned for specific applications, enabling them to create high-quality articles, blogs, and other written materials. Next is personalization. The process starts with collecting user data from sources like websites, apps, and social media. Integrated data pipelines using tools like Apache Kafka or Google Cloud Dataflow consolidate this data in real time. Real-time analytics platforms such as Apache Spark Streaming or AWS Kinesis process the data to extract insights, which feed into a personalization engine that generates tailored recommendations, content, and communications. These personalized interactions are delivered using APIs integrated with various platforms. To ensure low-latency responses, edge computing technologies like AWS Greengrass or Azure IoT Edge process data closer to the user. Additionally, there's automation. AI models trained on large datasets and using advanced algorithms automate these processes, improving efficiency and reducing costs. The technical backbone includes robotic process automation or RPA for executing repetitive tasks, AI-powered software tools for intelligent decision-making, and cloud services that provide the necessary scalability and support continuous learning and adaptation of the models. This infrastructure ensures that AI systems remain up-to-date and can handle increasing volumes of work effectively. And finally, innovation. Generative AI fosters innovation by simulating and modeling various scenarios to predict outcomes, aiding businesses in developing new products and services with higher success rates. This involves using advanced AI models for predictive analytics, scenario planning, and risk assessment, including techniques like regression analysis, time series forecasting, Monte Carlo simulations, Bayesian networks, and stress testing. Large datasets from diverse sources are processed using tools like Apache Hadoop and Apache Spark. Simulation tools such as digital twins and optimization algorithms are used to predict performance and find optimal solutions. From what you have learned in this video, it is clear that generative AI is a powerful tool that, when leveraged responsibly, can provide significant advantages to businesses by automating tasks, personalizing customer experiences, and driving innovation. you've gained an understanding of how generative AI continues to evolve, providing useful business applications. As the technology continues to evolve, it will likely become an even more integral part of the digital business landscape. It's no secret that generative AI has significantly transformed various job functions in the workplace. From automating routine tasks to enhancing creative processes, these systems use vast amounts of data to create new content, make predictions, and even make decisions. Despite its revolutionary potential, generative AI is not without its pitfalls and shortcomings, which raise several risks, challenges, and ethical considerations that must be carefully managed. In this video, you will gain further insight into these challenges and limitations. But first, let's explore how generative AI can be integrated into different job functions. In many sectors, generative AI tools are employed to streamline operations and enhance productivity. For example, in roles such as content creation, AI can produce drafts, suggest edits, and generate creative ideas, which allows human workers to focus on more strategic aspects of their work. Similarly, in software development, AI can write code, debug, and even test software, streamlining the development process and reducing time to market. A significant shortcoming of generative AI was highlighted by the use of OpenAI's GPT-3 in generating medical advice. In one instance, GPT-3 was used to provide mental health support, and it suggested to a simulated user experiencing distress to commit self-harm. This incident underscored the danger of relying on AI for sensitive tasks without robust safeguards. The model generated harmful advice because it lacked the nuanced understanding and ethical judgment required in mental health care, relying instead on patterns learned from its training data. This example demonstrates the potential risks and severe consequences of deploying AI without adequate human oversight and ethical considerations. These capabilities not only optimize efficiency, but also offer significant cost savings and scalability for growing businesses. However, the integration of AI into these roles is not always seamless. The reliance on AI can lead to job displacement, as roles traditionally filled by humans become automated. Furthermore, the quality of AI-generated outputs can be inconsistent. While AI excels in generating structured content, it struggles with tasks requiring deep understanding or emotional intelligence, often producing outputs that are awkward or contextually inappropriate. Earlier, you learned that businesses need to adopt ethical considerations given the potential for bias in AI-generated content. Since AI models learn from data, they inherently acquire the biases found in their training datasets. This can result in discriminatory practices, such as favoring one demographic group over another, when AI is used in HR for resume screening or job recommendations. Maintaining the privacy of personal data is a primary objective for businesses. When using generative AI systems to interact with personal data, care must be taken to ensure confidentiality and user privacy. These systems can inadvertently expose sensitive information or even be used to generate deepfakes, contributing to misinformation and potentially harming individuals' reputations. Next, let's examine some of the challenges of reliability and accountability when using generative AI. AI systems are notorious for their black box nature, meaning the processes they use to reach conclusions are not always clear. This lack of transparency can lead to reliability issues where businesses find it challenging to understand or predict the AI's behavior. This is particularly problematic in high-stakes environments like healthcare or finance, where unexpected AI decisions can have serious consequences. Accountability is another challenge. When errors occur, it's difficult to determine responsibility between the AI developers, the users, and the AI itself. This complicates legal and regulatory frameworks, which are often ill-equipped to handle the novel implications of AI technology. Despite their advanced capabilities, generative AI systems often lack common sense reasoning, a basic human ability to make practical judgments about everyday situations. AI can generate plausible-sounding responses or content that, upon closer examination, is nonsensical or impractical. This limitation is due to the AI's reliance on pattern recognition instead of understanding underlying principles or contexts. Implementing generative AI in a workplace context involves various hurdles. These include the technical challenge of integrating AI with existing IT systems, the need for significant investment in technology and training, and the ongoing requirement to update and maintain AI systems to adapt to new data or changing conditions. Additionally, if an organization is resistant to change and its staff are doubtful about AI, this can also make it harder to implement effectively. To reduce potential harm and ensure ethical AI deployment, it is crucial to adhere to guidelines like those set by major technology companies, including Microsoft. These guidelines emphasize fairness, reliability, privacy, inclusiveness, accountability, and transparency. Organizations must commit to rigorous testing and auditing of AI systems to identify and correct biases, protect data privacy, and ensure that AI systems perform as intended without infringing on ethical norms. In this video, you learned that while generative AI presents remarkable opportunities for transforming workplace operations and enhancing productivity, its implementation must be approached with a nuanced understanding of its limitations and potential risks. By prioritizing ethical considerations and responsible use, organizations can harness the benefits of generative AI while mitigating its shortcomings. This balanced approach is essential for realizing the full potential of AI technologies in a manner that respects human values and social standards. Generative AI stands at the forefront of a transformative era, reshaping our interaction with data and redefining the boundaries of creativity across diverse sectors. This innovative tool utilizes sophisticated statistical techniques to generate content across text, images, and code, empowering individuals and industries with remarkable capabilities. In this video, you'll gain an understanding of the multifaceted landscape of generative AI, exploring its vast capabilities, industry implications, and the career opportunities it presents. Before we get into more detail, let's answer the question, what is generative AI? Examples of these models are generative adversarial networks, or GANs, and transformer models. With these models, generative AI can create outputs that closely mimic human-made content. Using generative AI as an assistant can make a positive contribution across multiple industries. For example, imagine a trendy clothing store using generative AI to design unique patterns and styles based on customer preferences. With GANs, the AI could generate lifelike images of clothing designs, enabling the store to offer personalized options to each customer. This application not only enhances the shopping experience, but also streamlines the design process, illustrating how generative AI is reshaping industries through its creative capabilities. Now that you're up to speed on what generative AI is, let's explore some of its capabilities across different functions. Firstly, there's text generation, where generative AI models like Generative Pre-trained Transformer, or GPT, can compose essays, generate creative writing, automate customer support, and more. Imagine how generative AI can bring the store collection to life for shoppers, effortlessly crafting engaging product descriptions, captivating social media posts, and personalized customer communication that mimics the tone and style of human interaction. Next, there's image creation. Generative AI can transform textual descriptions into stunning visual representations. For the retail store, this means converting text into realistic images of new apparel designs, from elegant evening gowns to casual streetwear, providing the store's creative team with endless inspiration and flexibility in bringing their vision to life. This capability is revolutionizing fields such as graphic design, video game development, film production, and marketing and branding, where custom visuals can be created quickly and at scale. With audio production, the store's marketing and branding department uses generative AI's audio ability to synthesize speech, compose music, and create sound effects. Generative AI produces captivating audiovisual content for advertising campaigns, captivating audiences and enhancing brand visibility. In addition to its applications in creative fields like fashion, generative AI also showcases its capability in code generation. Imagine the retail store leveraging generative AI to optimize its online presence. AI would aid the store's programmers by suggesting improvements, completing lines of code, or even creating entire programs. This would not only streamline website development, but also enhance user experience, ensuring seamless navigation and captivating visuals for online shoppers. Finally, there is data synthesis. In the fashion world, staying ahead of the curve is crucial, and generative AI aids the store in achieving just that. It utilizes extensive data sets on fashion trends, customer preferences, and style influencers. The store can conduct market research and analyze customer behavior ethically and responsibly by generating synthetic data sets that maintain statistical properties without compromising individual privacy. This application is crucial for training more AI models where access to real data might be restricted or unethical. So, what are the industry implications of this emerging technology? The deployment of generative AI across various industries indicates a major shift in operational dynamics. In healthcare, AI-generated models can predict patient outcomes, personalize treatment plans, and automate administrative tasks. In finance, AI can manage risk assessment, automate trading, and personalize banking services. The creative industry is seeing an explosion of innovation and inspiration as generative AI-aided tools are contributing hugely to the fields of art, music, and literature, pushing the boundaries of traditional creativity. As AI evolves, its impact on the workforce and industry standards will be significant. The demand for AI knowledge is growing, and learning to work with AI will be crucial for career advancement in all fields. Jobs that traditionally didn't involve technology will start using AI tools more often. This shift will require professionals in most fields to develop new skills and undergo additional training to effectively integrate generative AI into their work. As a result, educational programs and workshops focusing on generative AI and its applications are becoming increasingly important, offering valuable resources for those looking to stay relevant and excel in their careers. Both businesses and individuals need to understand and adapt to generative AI's capabilities to fully harness its potential. Generative AI is not just a tool for creating and automating, it is a catalyst for innovation and transformation across all areas. In this video, you gained an understanding of the capabilities of generative AI and its implications for various industries. You also explored some of the career opportunities it will create. As we continue to explore and expand these technologies' capabilities, the opportunities for advancement and creativity are limitless. Welcome to the age of generative AI, where everyone has the chance to redefine the boundaries of what is possible.
And compliance concepts in problem solving, and adapting diagnostic skills to diverse IT and cloud problems, and managing Azure resources, including security and cost optimization. Completing this program demonstrates your job readiness and earns you a Coursera Professional Certificate. You can share it across your professional network. This professional certificate is designed and built by subject matter experts Every course has been created to equip you with theoretical and practical knowledge and real-life problem-solving skills to be successful in the IT and cloud support field. In developing this program, we carefully studied the job requirements for this role. By analyzing job postings and consulting with industry experts, we crafted a curriculum that covers the essential skills needed in today's business environment. You'll develop a strong foundation in IT and cloud support fundamentals. This holistic approach ensures that you gain a comprehensive understanding of both the technical and practical aspects of IT and cloud support. In each course, you'll be able to consolidate what you have learned by completing a project that simulates real-world IT and cloud scenarios. These skills are instrumental in becoming job-ready and include analyzing diagnostic tool outputs, recommending upgrades, diagnosing IT issues, implementing backup strategies, managing updates, enforcing compliance, monitoring resources, and creating disaster recovery plans in Azure. This program also prepares you for the Microsoft Certified Exam MS900, Microsoft 365 Fundamentals, and the Microsoft Certified Exam AZ900, Microsoft Azure Fundamentals. Passing these exams earns you a certification that provides industry-endorsed evidence of your skills, further enhancing your employability and career prospects. Congratulations on taking the first step. You're on your way to a successful career in the field of IT.
If you have any online accounts, such as those for email or social media, then you're no doubt familiar with the practice of setting a password for each one that is used to log in. To save yourself some trouble, perhaps you've developed the habit of using the same email address and password across several different accounts. While this creates convenience, it could also increase the risk of unauthorized access if you're not careful with your choice of password. In this video, you will learn why strong passwords are so important with any online account. You'll also discover the potential consequences of weak passwords and how a breach of one account can present a linked threat to other accounts. To help illustrate this threat, let's check in on Sam. Sam has been building a social media presence for Sam Scoops by creating accounts with different social media providers. Along with a personal email account, Sam also has a work email that she uses to take ice cream orders and field questions from customers. With so many different accounts to keep track of, Sam has opted for easy-to-remember passwords so they are not forgotten. Like many people, Sam's logic for coming up with a password involves tying it to personal data, like a birthday or something that is meaningful to her, like a pet's name. Sam does not want to lose access to these accounts or go through the password reset process, so keeping it simple seems to be the best option for her. Sam has chosen an email address and password combination for each social media account. She knows that it's a good idea to have different passwords on each account, so to keep it simple, she adds a number at the end of each one to make them a little different. Sam is happy with this approach of using different passwords, and she feels confident that her accounts are all well protected. However, there are a couple of problems. For one, each password contains the name of her favorite place. This information isn't known only to Sam, as she talks about it often on social media and with her friends. Many of these details are accessible to anyone else on the platform. Additionally, the practice of using incremental numbers in passwords is more common than Sam realizes, making it an easy pattern for attackers to pick up on. This weak password has allowed an attacker to easily guess the password to gain access to one of the accounts. This password has also allowed them easy access to the other newly created accounts. The attacker has also tried to gain access to one of the email accounts that is used by Sam to sign in and respond to clients, but this has failed. This is because, in contrast to her approach with the social media accounts, Sam has followed a strong password policy for her Sam Scoops email account. This policy requires a combination of uppercase and lowercase letters, numbers, special characters, and a length of at least 12 characters long. However, this is not the end of the attack, as now the hacker has access to one of the social media accounts. They can use this to send a message to one of Sam's colleagues, explaining that they need a password reset link. So Sam Scoops is now also exposed, even though they have a good password policy. Any attack that results in someone gaining unauthorized access to devices, services, or networks is considered a security breach. Imagine a security breach as similar to a break-in, where an intruder successfully breaks into a building. In Sam's case, the intruder was an attacker and the building was an online account. In this example, you've witnessed how Sam was exposed on several different fronts. First, one of her passwords was discovered due to it being weak, along with Sam leaving hints in her social media posts. Then, her usage of a predictable pattern led to her other passwords being compromised. Finally, a door is open for the attacker to use Sam's social media account to impersonate her and potentially access accounts associated with Sam Scoops. In this video, you learned that using weak passwords or reusing passwords on multiple accounts is a frequent practice that puts internet users at risk of account takeover, data compromise, and identity theft. This is already a big deal when it affects an individual, but the damage can be exponentially worse when a single breach impacts an entire network or organization. Having a strong password policy across all of your online accounts is critical to stop these linked threats. Think of Sam Scoops and all the employees working together to ensure the business runs smoothly. This might include attendants, dishwashers, and cashiers. While their duties are clearly defined, it doesn't mean that they work in isolation. Their tasks must be monitored to ensure that the whole team can work together without blocking each other. Computers work on a similar principle. Different components are competing for limited resources, and their access to such resources must be regulated to avoid conflict. This role is fulfilled by an operating system. In this video, you'll learn what exactly an operating system is. You'll be able to explain the role it plays and how it interacts with the various software and hardware components to create a smooth experience for the user. The operating system is the software component that interacts with the hardware and software programs to provide users with a standard computer experience. You can think of it as a go-between that starts up the computer hardware and file systems and allows for the interaction between multiple users, CPUs, and tasks. You can simplify the responsibilities of the operating system into three broad categories, which are controlling hardware access, providing a user interface, and managing files and applications. Let's explore each of these one at a time, starting with how an operating system controls hardware access. When interacting with the hardware of a computer, the operating system will communicate instructions through a device driver. These are essentially small pieces of code written by a device manufacturer which allow messages and instructions to be passed between the hardware and other software to control the device. Most devices are installed to a computer through a plug-and-play process, which means that a device connects to a computer and sends a signal to the operating system. The software then installs a device driver that enables interaction and stores this application's settings in a central location. This is saved in the registry on a Windows computer or the Preferences folder on a Mac. Plug-and-play comes from a time when all devices were physically connected, but these days devices can be connected digitally as well. Consider printers or any device found on the Internet of Things that can connect via Bluetooth, which are still examples of plug and play. You'll explore the Internet of Things in greater detail later on. Another role of an operating system is to provide a user interface, which facilitates the way a user communicates with the hardware and software of a computer. This interface is available in two forms. One is the command line or terminal window. You'll be familiar with this from many movies dealing with hackers breaking into computers. Command line or terminals allow for access to every part of a computer system, but require the user to provide very detailed instructions, often as programmer code. The other type is the graphical user interface. This is the most common way for users to interact with computer programs, including controlling the options for the operating system. It involves using a mouse to click on menus and icons to initiate programs. Most operating systems will provide the user with both CLI and GUI options. Finally, let's find out how an operating system manages files and applications. An application is a software program that performs a task. Microsoft Excel, Microsoft Word, or your web browser are examples of commercial applications that you likely use every day. However, users can also develop their own applications, which the operating system can run. An application will typically have an application programming interface, more commonly known as an API, which determines a set of rules for interacting with the program. In other words, an API ensures that a program is compatible with a given operating system. When an application is called for use through a user interface, the operating system loads the program from its place in memory into the RAM. Recall that RAM is immediate storage that holds files currently in use. The operating system then determines how much space and CPU power an application will be given. Some applications, such as a word processor, require relatively few resources, while others, such as a game with high-resolution graphics, are CPU-intensive and will dominate a computer's resources. In this video, you've received an overview of what an operating system is and the role it plays on a computer. You should now know that the responsibilities of an operating system fall into three general categories, which are controlling hardware access, providing a user interface, and managing files and applications. By now, you should be familiar with the role of an operating system and the several major types that are available. But what is the specific software that people are actually using? Despite the many options available, the modern operating system scene is dominated by just a few major competitors, each of which offer unique advantages over the others. In this video, you'll explore the 5 most popular operating systems in use today, which are Windows, Mac, Android, iOS, and Linux. You'll become aware of the key characteristics of each one and find out how they compare with each other. Recall that the core function of an operating system is to allow you to access various software and hardware components and to facilitate communication between them all. There are different types of operating systems that you may encounter, but all of them should fulfill this role. For desktop and laptop computers, the 3 most common operating systems are Microsoft Windows, Apple's Mac OS, and Linux. These are primarily found on PCs, whereas other devices such as phones, tablets, and music players run on different operating software because they have different specifications. The most notable examples of operating systems for mobile devices are Google Android and Apple iOS. So, why are there distinct operating systems across devices? Generally, a PC is expected to perform more complex, varied, and process-intensive tasks. As such, it requires a more sophisticated operating system. In contrast, mobile devices typically do not have the same memory or processing capacity, so mobile operating systems are tailored to instead maximize the device's resources and utilize them more efficiently. In spite of this, it's worth noting that the processing power found in a current-day phone is greater than that of the computers that were used to first send a man to the moon. Now that you know what the most popular operating systems are, let's explore them one at a time more deeply, starting with one of the oldest programs, which is Windows. Windows is proprietary software that is often preloaded into PCs as the default operating system. As such, the popularity of Windows ensures that developers are highly likely to make their applications compatible with this system. While Windows can be used with a command line interface, it heavily favors a graphical user interface approach. This means there is greater emphasis on pop-up menus and clickable icons as a means of navigating applications. The second most popular OS for computers is Apple's Mac OS. It is preloaded on all Apple computers and is also proprietary software, so users are discouraged from altering the code and instead should use the software as sold. As with Windows, it is typically used with a graphical user interface. While Apple and Windows are the systems of choice for PCs, mobile devices need something else to handle their unique needs. So let's move on to those next. First is Android, which receives regular updates and additional features. While it can be used for devices such as cameras and gaming consoles, this software is most frequently found on smartphones and tablets. Android is open source, making it highly customizable. Overall, Android is the most popular operating system for mobile devices worldwide. However, it does have one major competitor. Another mobile device OS, Apple's iOS, is a popular alternative to Android. A key difference is that rather than being available to numerous device makers, it is proprietary software that is exclusive to Apple products. Compared to Android, users have limited ability to customize the software. iOS is run on iPhones, iPads, and iPods, and is the second most widely used OS for mobile devices. Lastly, let's examine an operating system that doesn't currently have the mainstream appeal of the previous 4, but is noted for playing a large role in OS innovation. An alternative to proprietary software, Linux is an open source OS for both computing and mobile devices. This means that the code is freely available for people to alter as they feel fit. This has led to a large community of enthusiasts who develop and optimize many variations. Linux offers a command line interface, CLI, over a GUI-based approach. While Linux is not as widely distributed as Windows or Mac, it is popular for cloud computing and will likely experience growth as more people embrace this format. Mac OS is descended from Unix, and while similar to Linux, it is different enough that an Android app won't work on iOS. Windows now ships with a built-in Linux kernel, allowing Linux apps to run on Windows too. Now that you're familiar with the 5 major operating systems, let's observe each of them in action. Specifically, you'll witness the startup process of each one, along with the interface that is first presented once that process completes. In a typical Windows setup, you'll begin by logging in with a password. After a few moments, you'll arrive at the desktop, which is the main workspace and a core part of the Windows GUI. The bar at the bottom is the taskbar. This can hold several apps at once, making it easy to switch between them. Starting up macOS is similar to Windows, and you'll need to log in first. A difference you might notice this time around is the bar with the icons. This is the dock, and you can customize it to hold your favorite apps so that you can access them more quickly. On the mobile side, you have Android. Most Android devices can be unlocked with a PIN or a biometric feature like a fingerprint. Because the software is open source, the appearance, capabilities, and the overall experience of one device can be different from those of another. This depends on how the manufacturer has altered it. The other major mobile operating system is iOS, which you'll find on Apple devices like the iPhone and iPad. The software can't be customized as much as Android, but it's well known for giving a consistent experience across different devices. And finally, there is Linux. Linux is open source and has a very active developer community, which means that it takes on many forms. One of the most popular versions for cloud computing is Ubuntu. This is because cloud computing relies on resources that are stored online, and Ubuntu can access these resources with both speed and security. In this video, you've become familiar with the 5 most popular operating systems for both computers and mobile devices. You should now be aware that Windows, Mac, and Linux are the most common programs for desktops and laptops, while Android and iOS are the dominant software for smartphones and tablets. Do you remember a time when you were rushing to complete a task for a deadline, and at the last minute, something unforeseen happened which interrupted your progress? Perhaps you were uploading important information and your internet connection dropped. Do you recall working on your computer where you saved all your confidential or project information that you've been tackling for months? Suddenly, your device gave in, leaving you frustrated and panicked because you're held accountable and there's no recourse to restore your data. Imagine the impact on an enterprise when a large volume of data is lost. There are solutions to avoid the devastation experienced in situations such as these. System fail-safe protection forms part of enterprise systems and security. In this video, you'll establish the relationship between system fail-safe protection and servers, storage, and backups. Specifically, you'll find answers to questions such as, what computer environments will an application run on? Are there backups? And what maintenance and patching policies are employable? Let's begin by discussing servers. A server is considered to have several meanings and various roles in relation to computers. Predominantly, a server is a piece of programming code that provides services. This can also take the form of computers on a computer network. Additionally, it can be defined as a computer dedicated to running programs. There are various types of servers, but let's unpack the 2 most common ones, web servers and database servers. A web server is a computer that is dedicated full-time to hosting web pages. The internet is made up of many computers acting as web servers, connected with the appropriate ports and protocols. It can be a single web page of a small business running on a personal computer, or a large multinational company hosting thousands of pages. Nevertheless, it is all interconnected and accessible to everyone. An unfavorable expression that you may have encountered is, the server is down. This means that the computer hosting the web pages for a company or an individual is no longer accessible and the service has ceased. Soon you'll learn some cybersecurity best practices that will make this expression less likely to come up. Another type of server is a database server. A database server is a machine that is dedicated to storing information. It is connected to a network and accessed when stored data is required. Before continuing, let's observe a scenario that involves storing data for a business. Sam is considering the storage needs for Sam Scoops. Here are some important considerations when assessing storage needs and requirements. One is durability. Good questions to ask when assessing durability is, will it last? And what is an acceptable period of time to measure durability? Another is scalability. Does it fit the data needs of the business? Or does your storage solution adjust accordingly as the business need grows? Next, availability concerns how readily available the data is and when it is needed. Lastly, consider security. How safe is your data? Ultimately, Sam wants to ensure that the essential data needed to run Sam Scoops is kept safe. This means potentially duplicating the data and storing it in a secondary location. This process is known as creating a backup. It is good practice to exercise when running a business. With the scenario in mind, let's explore storage. When a server goes down, the server hosting your web page is unreachable. This may be due to a technical error like losing an internet connection or an issue with the computer hosting the server. Recall that memory is either volatile or non-volatile. In the instance that a computer no longer runs, any data stored in volatile memory is lost. Therefore, it is vital to create a backup and save your memory to secondary storage regularly. Additionally, your server may require large amounts of data to satisfy requested tasks. RAM is a short-term solution, and its storage and memory retention are quite limited. When faced with this issue, a business can address the problem in two ways. The first option is to physically acquire more storage through what is known as direct area storage, or DAS. DAS involves additional secondary storage devices that physically connect to the machine accessing it. Some examples include solid-state drives or hard disk drives, along with flash drives and legacy devices like floppy disks and DVDs. Alternatively, another option is to make use of cloud storage. Some major cloud storage providers include Microsoft Azure, Amazon Web Services, and Google Cloud Platform. Cloud computing works on the same principle as a home database server, except it is done on a larger scale with potentially unlimited data restrictions available. The only limitation is that there is a cost attached to cloud services. So, Sam can back up important data regularly by either exploring the DAS route with a physical installation or investing in a cloud storage provider. In this video, you discovered that a server can take many forms. You are familiar with the internet model that is made up of web servers. A database server, however, can act as a database for your business. You also learned that it is good practice to keep duplicates of your information by creating backups that run periodically. This protects your information if anything happens to your primary dataset and allows you to restore an earlier version. If you've ever gone shopping for computers, you've no doubt noticed the wide range in prices across machines that perform essentially the same tasks. So why would anyone pay more? Well, beneath the similar exteriors are components with vast differences in power and capacity, and sometimes distinct specialized parts entirely. Depending on the task, choosing a computer with capable specifications is critical for achieving solid performance. Earlier, you were introduced to the various components that comprise a computer. Recall that this includes RAM, a CPU, a motherboard, and various input and output devices. Additionally, you learned about different operating systems and how they are used to interface between the user and the machinery. You then expanded this knowledge to include the concepts of servers and storage. Now that you are familiar with each of these individual topics, it's time to combine them and find out how they work together to make up computing environments. In this video, you'll learn how to distinguish between personal, commercial, and cloud computing, and you'll be able to describe the general usage scenarios that each one is best suited for. Currently, Sam uses computers to answer questions and fulfill orders sent through email. She's aware that changes will be necessary to handle the higher volume as they gain customers. However, Sam is unsure which direction to take and has asked you to help define the differences between the computers that people use at home and those used by businesses. Let's begin by defining and comparing personal and commercial computers. As you may have guessed by the names, personal computers are typically intended for individual use, while commercial computers are more likely to be the choice of businesses and organizations. Put simply, the primary difference between the two comes down to size and processing power. But let's explore why this is and what it means in real-world use. For a typical person using a computer at home, activities are confined to web surfing, editing documents, watching videos, and running a few applications. With a few exceptions, these activities do not consume excessive computer resources, so there is no need for top-tier components. In contrast, commercial-grade computers are expected to handle more significant tasks that usually require more memory and greater CPU power. Depending on the nature of the business, there might also be a need for graphics cards or other specialized hardware components to perform the business need. Thus, while a single core processor may be sufficient for personal use, commercial computers may require a quad core to handle processing and networking with other computers. The larger workloads on commercial computers might also demand more durable motherboards, circuitry, and casing, leading to a higher cost than for the same parts on a personal computer. However, note that commercial computing isn't the only option for companies these days. While commercial computers were the business norm for many years, the rise of high-speed internet and online data storage have enabled another type of computing environment: cloud computing. This has gained popularity as a solution due to certain advantages when it comes to scalability and reliability, among other benefits that you'll learn more about later. The main difference between commercial computers and cloud computing is the location. But before you explore what that entails, let's take a step back for a moment. While personal and commercial computers have their differences, as you recently learned, the fundamental processes they go through are ultimately the same. Both types take input, access stored resources, process the input, and store or return the result. However, how these ends are achieved differs from a traditional in-house commercial setup and cloud computing. Let's find out how that is. The input types are common to all three approaches: a keyboard, mouse, touchscreen, or another input device used to take input, which is then loaded into the RAM. With personal and commercial computers, RAM can be stored on the machine taking the input, or the task may be sent to an in-house application server. In cloud computing, however, this input is sent using an online network to RAM on the cloud. Consider what you previously learned about servers and how a computer can be dedicated to just running applications or storing information. Cloud computing is a server dedicated to processing, storing, or running data and applications. The fundamental difference between cloud and traditional on-premises or personal computers is that the hardware that performs these actions does not need to be purchased. Instead, the business requests an online network to perform a task, the results of which are stored or returned from an external site. There are different cloud models that are used to make this happen, which will be covered in detail later. In this video, you learned about the key differences between personal, commercial, and cloud computing environments. You discovered that while each approach handles input, storage, processing, and output differently, the core components that perform these operations are the same. You also learned how these approaches apply to different usages. Specifically, you found out that personal computers rarely require massive computation, and smaller, less power-intensive parts can be used. An on-premises business can expand its size using servers and more heavy-grade hardware, distributing tasks on local application servers. And finally, a cloud-based company can utilize the industrial-grade components found with cloud computing utilizing the internet. You were recently introduced to the methods used by businesses for handling digital data, specifically the on-premises approach that utilizes local physical hardware, and cloud computing, which uses the internet to push those duties to external parties. You also already know about the potential cyber threats faced by an individual computer user and how to safeguard against them. But what happens when the data of an entire organization is at stake? By the end of this video, you'll come to understand the security issues that concern both on-premises and cloud-based computing environments. You'll also leave with a stronger grasp of the measures that are taken to improve security within each approach. Previously, you became familiar with the traditional methods for implementing security on home computers. Every personal computer being used to access this video has a firewall filtering the incoming traffic to ensure no malicious code is allowed in, which could cause the computer to perform in ways contrary to the user's expectations. Every computer also runs antivirus software designed to detect and remove any malicious code that does make it through. These same principles of preventative and responsive measures extend to commercial computing, both traditional and cloud-based. However, the implementation may differ due to the particular challenges of each approach. Fundamentally, the steps are the same. Stop unauthorized access, limit mobility within a system once accessed, and employ a backup strategy that will help recover from any damage done through unauthorized access to a system. Although both approaches to running a business target the same goal, there are some differences in how these steps are carried out. Let's find out what those are, starting with traditional computing. Recall that traditional computing keeps the computing infrastructure of the company on premises. This means the data does not have to move across different internet lines to be processed and stored. This can be highly beneficial to companies that operate under strict regulatory requirements. The software used to maintain this data is also behind the traditional on-premises security measures, so they offer greater protection. So if an attacker manages to gain access to a company's internal operations, they will have to overcome the internal measures implemented to reduce unauthorized access. On-premises housing also means that security is physical. Unlike virtual protection, on-premises security must ensure the physical well-being of the computers. Being able to access the hardware physically could allow an attacker the opportunity to upload some malicious code. Typically, a business will guard against this through security guards, worker ID cards, segregated section access, and good sturdy locks. Further measures may include security cameras and tracking software on the computers. In contrast, with cloud computing, data protection duties are outsourced to a third party, and as such, the company will have less control over how it is protected. You'll later learn more about the specific breaches, fallouts, and other dangers that this can leave data more vulnerable to. Some might argue that the security measures implemented by these multinational providers would require more work to replicate on premises, but ultimately, the level of security is only as helpful as the measures implemented. Establishing good policies and procedures is vital, regardless of how large the lock guarding your door is. It is only useful if the building is secure. This principle is true when applied to on-site security and cloud-based security alike. Access to cyber infrastructure is gained through gateways. This means the first step in protecting data is monitoring traffic. All incoming traffic is vetted before it can access the system. Next, an organization will consider managing the endpoints. An endpoint is any destination from a communication channel. Common organization endpoints could include mobile devices, desktop computers, virtual machines, which can be thought of as cloud desktops, servers, and embedded devices or any specialized devices needed for executing the business needs. As noted, a physical measure for protecting a business is providing authorization cards for employees cleared to be in a given area. So how can such a policy be enforced in the absence of physical locations within cloud computing? That can be done with the cyber equivalent of this practice, which is known as Identity and Access Management, or IAM. Microsoft's Azure, a popular cloud computing platform, can provide all the cloud-based requirements a business may need. Azure has a dedicated IAM called Active Directory, which ensures that access to specific documentation and services is only given to the appropriate people. You'll explore how this is implemented later on. Such management methods are crucial to protecting a business's digital assets because it's not enough to only monitor who gains access. There must also be a means to control what changes they are allowed to perform. Finally, one of the strongest measures a company can employ, whether on-premises or cloud-based, is to provide technical training for staff. Knowing what dangers a company faces is half the battle of avoiding them, so a well-trained workforce is key to organizational security. In this video, you are made aware of some security concerns faced by on-premises and cloud-based companies. Some of the high-level concepts you were introduced to include how to access company resources, what movement is allowed to a person once inside, and the various endpoints that a hacker might attack. Why are updates necessary? This is something that Sam from Sam's Scoops always wondered about, but didn't pay close attention to. Sam Scoops is flourishing with the sudden growth it's experiencing in the community. Sam knows that the envisioned expansion of the business is achievable if the company continues this path of success. As it stands, the workload has increased so much that more hands and additional devices would make life easier. While working at such a fast pace, Sam makes a common mistake by postponing the computer updates to a less busy day. However, so many days have passed and they notice that the computer software is slowing down. In addition, and unexpectedly, Sam receives a notification a day later asking for a ransom to release the business's confidential information. If Sam doesn't comply and pay the ransom, the cyber criminals will delete everything on the computer and begin targeting customers. Hopefully, you've never experienced a ransomware attack like this. Even if you haven't, you should ask yourself a question. Is your device currently up to date, or are you vulnerable to a cyber attack? In this video, you'll unpack what maintenance and patching are and why they are essential in reducing vulnerabilities. Software updates take an existing piece of code and alter it. Motivations for this include adding and improving functionality, addressing and enhancing a security-related element, and removing bugs that affect how a program operates. Let's begin by learning what patches are. Patches are for newly identified shortcomings or dangers in existing software. They are small pieces of code that only modify the target area without impacting the general function of an application. The code deployed is never perfect. Over time, incompatibilities or issues are identified. If the issue is determined to pose an immediate danger to a system, then a patch will be issued to address the issue immediately. Later, at a scheduled update, a more permanent solution will be deployed. There are two categories of patches. First, a bug fix patch is when an issue is identified with the code and the patch temporarily covers it. The second type is a security patch. It is when a vulnerability that can be exploited for malicious intent is identified. A security patch is then issued to make the software more secure. Patches can be very useful because they either enhance existing software or make it more robust against attack. So where does maintenance fit in? While patches are designed to prevent and mediate issues with code, maintenance is defined as all the changes made to a code after deployment. This includes all the patches and updates. An update contains security and quality revisions and significant feature additions and changes. Maintenance is done during special maintenance windows and can include a scan for any malware and viruses. A patch is further distinguished by how it is implemented. A hot patch is an alteration to the code that does not require a system reboot. A cold patch requires the system to be rebooted before the update becomes active. Understandably, this can disrupt operations. Regular maintenance avoids or eliminates the need to repair an item. Patches and updates are the processes by which software is maintained and enhanced by companies. Some individuals, however, choose not to implement patches based on the conclusion that if there is no issues, then why issue an update? Alternatively, a user may be engaged in a task and the update requires restarting the machine, so they are often tempted to put off implementing the patch. Generally, updates relate only to functionality, but it is important to implement them because some updates include patches that have security-related elements. By updating regularly, your device will be less vulnerable to cyber attacks. Let's examine the following use cases where users were vulnerable to cyber attacks because they put off their update installations. In May 2017, a ransomware attack called WannaCry affected millions of computers. This attack exploited a shortcoming of Microsoft devices. It resulted in encryption software being installed on these devices. The information was held for ransom by the attackers. WannaCry is an instance of a zero-day exploit. This is an attack done on a detected unknown flaw in a type of software. There's no prior knowledge of the flaw and therefore no defense to fight against it. So Microsoft urgently released a patch to close the loop that allowed unlawful access to prevent similar future cyber attacks. It's important to note that the patch closed the gateway that the cyber criminals used to enter the system. It did not lead to a decryption of the affected software. Initially, affected users were forced to pay the ransom or to accept the data loss on their computers. You may have heard of another virus called Petya that exploited the same vulnerability. Computers affected by Petya were systems that were vulnerable because they did not download and install the Microsoft patch. So think twice before putting off your update installations. In this video, you learn to differentiate between patches and maintenance and why it is essential in reducing vulnerabilities. You now realize that an update might relate to adding features or performance-related pieces of code. You learned that a patch is designed to address a shortcoming or security risk. Remember that an update may include a vital patch, so paying attention to updates is always advisable. Patching is a computer practice that is as old as computers themselves. In fact, the term patch dates back to a time when computing was performed using punch cards. A programmer would mark the code on stiff paper through a series of holes or punches. Updating or changing this code entailed removing certain holes, which was done by placing patches in their place. And so, this practice of identifying updates as patches remains in use today. Applying patches and updates is an essential routine for ensuring your application's longevity and safety. Users sometimes view update notifications as unnecessary and choose to ignore pending updates. However, doing so carries some risks. In this video, you'll become familiar with the primary benefits of patches, as well as some of the negative aspects that may deter users from committing to them. To begin, let's consider some of the advantages to accepting patches and updates. When a vulnerability is discovered in an application, the developer responds with a patch to mitigate the risk of infection. However, announcing the vulnerability does mean that both good actors and bad ones become aware of its existence. The fact that the patch exists is a reason to apply it, because the issue is now also known to potential hackers. Patches can also prevent breaches that expose sensitive data. A company's reputation becomes severely damaged when they cannot protect their customers' information. So, a patch helps to mitigate potential breaches when vulnerabilities become known and keeps the company in high regard. Keeping devices up to date helps to prevent other devices on a network from becoming infected. If a seemingly minor device on your network is attacked, then patching it could potentially seal a gateway through which more important systems are impacted. Even when vulnerabilities aren't an issue, patches are often developed to fix bugs or other flaws in a system that might affect performance, and to prevent system crashes and periods of offline activity that would halt productivity. Keep in mind that updates aren't limited to addressing vulnerabilities or fixing things that are wrong. There are other reasons why you might want to add patches. For example, they ensure that your system stays compatible with contemporary software, which itself is being updated constantly. With all these benefits, why wouldn't a user want to install all updates that become available? Well, they are often viewed as a disruptive procedure and may also result in unwanted changes to an application or workflow. Let's observe some of the specific difficulties that are frequently brought up. For one, a business may need to take a critical system offline to perform an update. This can hinder the operations of a business significantly, so some companies are understandably hesitant. Often, necessary updates are scheduled for appropriate times that produce the least impact. There are also concerns of how an update can make a familiar working environment unfamiliar by changing the layout or removing previously used elements. Some patches also add functionality that is not required and may even degrade the performance of other features. Some users become reluctant to accept updates due to poor experiences that change the interface in a way that was undesirable. Finally, there are worries about effects on productivity. For example, a system may experience lag or require a restart to implement the patch. This in turn slows or halts any other activities in progress, which deters many users from implementing a patch. The very act of installing an update can also break the flow of concentration if a notification appears at an inconvenient time, and deferring once or twice can quickly build into a habit. In this video, you were introduced to some of the pros and cons of accepting updates and patches. Some of the inconveniences include breaking the flow of your work, temporarily having to take your system offline, and potentially changing layout or otherwise altering the flow of a once familiar program. However, most users would likely agree that the advantages of implementing updates outweighs the inconveniences, namely the lowered risk of attack, increased safety for other devices on the network, elimination of bugs and flaws, and improved performance and productivity in the long term. With technology today and the fierce competitive market, how efficient is a business that persists in using a paper-based system? Sam from Sam Scoops realizes that business growth includes revisiting processes and investigating ways to become operationally efficient. With many tasks still carried out on paper, the time spent doing this can be time spent elsewhere. On longer days under increased pressure, Sam has noticed that sometimes mistakes are made when undertaking tasks manually. She's ready to consider which business software applications would benefit the business by saving time and minimizing human error. In this video, you'll begin differentiating between a business need and business software. You'll explore different types of software applications with common business functions. A company's business need relates to all the business requirements, including achieving the money-making aspect of a company. In other words, it's all the software and services used to execute business functions. Specifically, these needs include financial analysis and growth, customer management and analysis, increasing revenue, payroll management, product development, and financial management. The business function relates to a specific task it executes. For example, within Sam Scoop's ice cream shop, these are aspects related to running the business, such as hiring and paying staff, orders, communicating with customers and providers, maintaining inventory, and marketing. Business software consists of applications that help businesses reach their goals. This is either existing or generic software packages for certain aspects of the business need, or a software package that is customized to a company's needs. For example, Sam Scoops may require software that will allow them to take orders online, organize a timetable, schedule deliveries, and manage customer invoices. Some activities are general tasks like bookkeeping and invoice generating, and others involve software designed specifically for a company, such as customer relationship management or CRM. So, what is CRM software? Business applications originate from CRM systems. It began with a process for managing a customer's interaction with a business. This interaction comprised of providing software to enable communication between the company and the customer, managing the software, and providing detailed analysis of the information gathered about the interaction. The techniques and tools benefit various departments, including human resources, marketing, sales, and financial reporting. These services are called line of business solutions and enterprise resource planning. Essentially, line of business is a set of products that services a specific business need. Enterprise resource planning is management software that integrates processes through a central system. Business software can refer to a single application, such as a word processing program. It can also consist of a combined service with many individual solutions, such as a collection with word processing, spreadsheets, and presentation software. Let's explore some of the ways in which a business software package might benefit a company, especially a small one that needs to be mindful of its budget. Imagine for now that Sam has decided to purchase some software to help perform daily tasks at Sam Scoops. She only wants applications for creating invoices, keeping track of financial records, and creating marketing material. However, she notices that business software collections always seem to have programs that she doesn't currently need, such as applications for payroll management. Fortunately, many businesses, from small ones to large multinationals, are using cloud services for access to their modern solutions. These solutions offer different packages for different needs, which are available at multiple price tiers. This means that Sam isn't stuck paying extra for software she won't use. The rise of cloud storage for businesses gives Sam even greater flexibility. For example, instead of paying a high upfront cost for a large local storage device, she can pay less for lower capacity online storage. This way, Sam can pay only for the space she needs immediately and can expand the capacity later on if necessary. Many business software solutions provide integrated cloud storage, making this entire process even more seamless. In this video, you've been introduced to various business software applications. You now understand what business needs are and that it extends beyond the services a business provides. It also includes all the services needed to enable a company to execute this, such as sales, marketing, and payroll. You can confidently identify the operations that some CRMs provide, and you explored how business software packages come in multiple forms that cater to both large and small businesses. Sam Scoops is constantly evolving. The success of the business is steadily growing, and the need to continuously evaluate internal processes is vital. Sam acknowledges that some improvements to better daily tasks are necessary. She also finds it difficult to manage the ice cream shop operationally and implement changes. However, Sam has decided to give the recommended software applications a go to complete her daily tasks. Previously, you engaged in an exercise where you began to apply your knowledge of software applications in response to business needs. In this video, you'll examine how business applications are beneficial and can be used in everyday business tasks. You'll form the big picture of the role and importance of these system applications through the use case of Sam Scoops. Sam wants to create a menu for Sam Scoops. To do so, Sam decides to use Microsoft PowerPoint. This is a good choice because PowerPoint has built-in templates to choose from. This will cut down on the time it would take to design a menu from scratch. So, Sam opens PowerPoint and selects the New section. She then navigates to the Template section to search for a pre-existing design that can quickly be adapted. Sam settles on a template with clean, appealing design and proceeds to populate it with the names of the shop's ice cream flavors. Sam then personalizes the menu into something that suits the Sam Scoops brand. This is easily done by replacing the fonts, colors, and images. Next, Sam searches for a way to convert her static menu into something more exciting, such as a video. She intends to play the video on the screen in store. After spending some time researching, she discovers that PowerPoint has the option to animate the on-screen elements of her menu and export it in video format. With that, Sam has completed 2 tasks in one sitting, using one software application. This has not only saved time, but also avoided additional production costs to create the video. Next, Sam needs an immediate solution to creating customer invoices. Sam realizes that Microsoft Word has built-in templates. So she opens Microsoft Word and selects the New tab. In the Template section, Sam conducts a search for invoice. There, Sam selects a template she likes and that is simple to amend. The key elements of the invoice form are there, so all Sam needs to do is fill in the company details. Within minutes, the document has been personalized and is ready for use. The invoice is already in pretty good shape. But Sam decides that rather than just displaying the company name in text, she would like to use the logo. To do so, she deletes the name in the upper left corner and then inserts an image of the logo from her computer. However, it takes up too much space on the page. Not a problem. She can simply resize it until she finds the perfect fit. Now it's complete. Sam doesn't want to add these details every time she prepares a new invoice, and fortunately, she won't have to. She can save her work as a custom template and then open it next time and enter customer information right away. Now, just one task remains. Sam has been putting off doing the budget plan for the coming month. Up until now, she has a book logging the budgets for Sam Scoops. It's a time-consuming process and currently not a document that can be easily shared. A budget is required to make sure that the outgoing orders match the incoming capital. Without wasting more time, Sam has learned that Microsoft Excel is suited for this purpose. Sam opens the app and selects the New tab. There is a range of budget templates appropriate for every occasion. By selecting an appropriate one, Sam confidently plans the budget for the coming month. As with the invoice, Sam can personalize the template and quickly fill it in with financial details from Sam Scoops. Sam now has the data in a table, but she wants to take things a step further. To gather insights more easily, she would like to present the same data in a more visual format. She's in luck. Sam can simply select the desired data and then use Excel's pie chart tool to instantly produce a chart that allows her to interpret the information from a different angle. In this video, you examined readily available business software applications that a small business can use. Specifically, 3 Microsoft business applications were used to improve day-to-day tasks for Sam Scoops by using existing templates rather than starting from scratch. The approach with each application followed the same steps. You'll investigate more advanced tools as the business's needs grow. How has email changed the way we do business? Let's look at this example. Sam is sitting with some friends and having some coffee. There is a beep as Sam's phone informs her that she has received an email. The email relates to a significant order that needs Sam's immediate attention. Without leaving the restaurant, Sam can dispatch this piece of business. As Sam puts away the phone, she marvels at how incredible the power of email is. In this video, you will learn how communication has shaped the world. You will also learn what happens behind the scenes as an email makes its way to the recipient. Before email, the main form of written communication was the letter. Letters were transferred in what later became known as snail mail, a name that conveys the slowness of the medium. Despite this, it played a critical role in spreading world-changing ideas. Post was the means that conquered the Wild West in America. It traveled on horseback, stagecoach, and later trains. The Constitutional Post was founded in 1774 to oppose the British-run post. Because letters were regularly intercepted and read, many felt that revolutionary ideas needed to pass undetected. Mail was designed to spread information and was seen as an aid in developing an informed electorate. In modern times, written communication has evolved and moved from a physical delivery method to an electronic one. The first email was created in 1965 at Massachusetts Institute of Technology. 6 years later, the electronic mail system was introduced by Ray Tomlinson, who also introduced the @ symbol as a means of address. In 1978, the Defense Advanced Research Projects Agency, or DARPA, introduced the standardization TCP/IP process used today. Microsoft Mail, which would grow into Office 365, was introduced in 1988. Email fundamentally changed how people communicate. While before you could write your thoughts on a piece of paper and have them delivered to a family or entire village, you could now type one message by email and have it copied multiple times. This also had a significant impact on how business is done. Consider mailing lists. Interested parties subscribe to a certain service from which they receive regular updates in a timely fashion. Vendors also benefit as they can reach a wider audience of interested parties. Without email, online shopping would become particularly challenging. Email allows for instant interaction between seller and buyer from any two parts of the world. Coupled with online payment systems and worldwide delivery services, this has created a global marketplace. So, how does email work? To find out, let's follow the journey of one email as it goes from sender to recipient. First, someone types an email and, using a computer with an internet connection, sends this to an email server. In previous lessons, you learned that different servers perform different tasks, which they are named after. The email server serves mail. The sender uses a simple mail transfer protocol, or SMTP. Protocols are the backbone of the internet and will be covered extensively later on. For now, we can say that a protocol is a series of predefined steps for achieving a goal. The task of this protocol is to take the mail from the sender and direct it to the recipient using an IP address. An IP address is much like a postcode. It's the location of the destination. The email bounces between servers until it reaches the destination server. The recipient is then notified and the message is retrieved using another protocol called POP3. You will learn more about POP3 and SMTP later on. For now, it's important to know that they are the protocols used to send and receive email. Earlier in this video, you learned about how snail mail progressed to email. Fundamentally, it is about transferring information. The change in communication styles was heavily impacted in the 19th and 20th centuries with globalization. Communication was affected by and added to this process. After the stagecoach, messages were relayed using steamships and railroads. They became digitally transformed with the introduction of the telegraph system, which enabled people to send information through dots and dashes transferred across land using wires. What is significant about telegrams, as with emails, messages do not need to be physically transported. They are no longer tethered to the train or stagecoach. This leads to an almost instant transfer of information. Today, this is a familiar concept. Mobile phones enable you to send text, images, and video at the touch of a button. Consider some of the revolutionary photos from journalists that have captured a poignant moment in history. Now with phones, every incident is being recorded from different angles and streamed to the world in real time. A lot has changed since the humble origins of the written page. Many social media platforms now offer instant messaging as a service, as well as the means to stream to a global community. In this video, you learned about how email has revolutionized the world and enabled instant communication. While you might take email for granted these days, it was not always widely accepted. Now it is part of everyday life and influences how people live and conduct business. Imagine that you have an inbox filled with hundreds or perhaps thousands of emails that you've received over time. You don't want to delete them in case there are a few that will become useful later, but it can also be a headache dealing with an unorganized mess. So what can you do? Fortunately, modern email clients offer features that make it easier to manage your email. Earlier, you learned about the client-server model, where the client sends a request to the server, which then responds with a service. In this video, you'll discover how this model applies to email, allowing you to access your messages through either an email server or an email client. After learning how they differ, you'll then explore 3 popular email clients. Earlier, you were introduced to email servers, which are specialized servers devoted to sending and receiving emails. It is hosted by your email provider and resides on the internet. Recall that emails are sent using the simple mail transfer protocol and retrieved with the POP3 protocol. Alternatively, you could use an email client, which is typically an application that you install on your computer. A major advantage of an email client is that it allows you to access your existing messages without being online. There are many options available, and some of the most popular include Outlook, Gmail, and Thunderbird. Let's observe each of these in action, starting with Outlook. Outlook allows you to create and send emails. In addition, it allows you to keep a contact list, provides a calendar, and supports add-ons such as instant messaging applications like Microsoft Teams and Skype. The calendar is linked with your contacts, so it is possible to coordinate meetings in which you add participants through the contacts. Outlook is linked with OneDrive and offers 5 GB of cloud storage for free, but this can be increased to up to 1 TB with a subscription. Outlook is both an email server and an email client, so it is possible to configure it with other email addresses regardless of their domain. With this arrangement, changes made to your connected account will be reflected in Outlook, but changes to Outlook will not be reflected in the connected account. Outlook has a 3-window approach to presenting information. By default, your folder list appears on the left, your most recent emails in the middle, and the contents of a selected email on the right. Creating nested folders for storing emails that act like a directory is possible. This can help organize your emails. There is also functionality for searching, protecting yourself from spam messages, and filtering emails into specific folders. Note that the features available depend on the payment plan you choose. However, there is a free version that will include ads. Next, let's move on to Google's email service, Gmail. Gmail provides all the standard email features, such as sending and receiving messages, and functionalities for searching, filtering, and categorization. It does not provide a folder option. Instead, it uses labels to organize your data. Being a Google product, Gmail features an interface like what you would find on YouTube or Chrome. The display has 2 panes, one for the inbox and labels, and the other to display the contents of the inbox or selected label. Gmail does not provide a computer application, so you need to use a browser to interface with the server. This means that an internet connection is required to access emails. However, there is a Gmail app for mobile devices, so you can use it to access any emails that have already been retrieved. Gmail is connected to Google Drive, Google's cloud storage service. It also offers 15 GB of storage space and displays ads, while paid subscriptions would increase this amount. This makes it possible to send large files of any format by first uploading it to Gmail. Finally, there is Thunderbird, an email client from Mozilla. Thunderbird is a cross-platform client that is compatible with all email servers. It provides only a few of the features that are built into the other proprietary email clients you just learned about. As with Outlook, you can create new directories for sorting emails. Thunderbird does not include cloud storage, which means that the size of the emails is limited to the server configuration Thunderbird has been linked to. However, Thunderbird is open source, which means that it is customizable and ad-free. Other built-in features include contacts, a calendar, and a to-do list. The interface consists of 3 panes. The left is a list of tasks, the top right is a list of emails, and the bottom is the selected email. While it lacks the training documentation and support options available for Outlook or Gmail, Thunderbird is supported by a vibrant and active community of users and developers. In this video, you learned how to distinguish between an email server and an email client. You were also made aware of the features of 3 popular email clients, which are Outlook, Gmail, and Thunderbird. You found that as proprietary packages, Outlook and Gmail offer integration with other applications, while the open source Thunderbird allows for a more customizable experience. As SAM Scoops expands, the use of on-premises computers and other online devices will increase. Sam knows that she will need data management and storage solutions to run the store efficiently and avoid any data loss or vulnerabilities. So she has been researching options that can meet her business needs. She is looking for a solution that allows for more storage as the business grows. It should also keep information secure and gather insights to help make more informed decisions. Is there something out there that will be the right fit for Sam Scoops? In this video, you'll discover online storage and how it can be tailored to a specific business need. Specifically, you'll focus on Microsoft Azure storage. Cloud-based computing is an approach that functions as a pay-as-you-use service. You can use online services instead of purchasing any hardware. Cloud storage enables you to access suitable storage sizes as the business requires. There are different formats in which the data can be retained. Microsoft Azure, an online storage solution, is an important topic to grasp for exam SC900. Let's explore this further. The Azure Storage Platform includes the following data services: Azure Files, which manages file sharing for cloud-based storage; Azure Blob Storage, which is a scalable object store for text and binary data; and Azure Managed Disks, which involves block-level storage that's accessible using virtual machines. Azure allows data access through several methods, including HTTP, HTTPS, and REST API. This is the same as accessing a web page by typing the URL in the search bar. The difference is that you first need to be authorized to access these sites. This can be useful for remote collaboration. For example, say there is a document saved in Azure Files that is edited by several employees. They can access the document from various locations, but each employee first needs to log in securely to gain access. Data is categorized as structured or unstructured data. Let's begin by discussing structured data. When you fill out a form, each column has a name and a place to enter the appropriate data. This is an example of structured data. Another example is a database table. In every table, there are rows and columns, and each of the values in the columns relates to the row. In databases, information is ordered according to the schema. The schema is the template a database uses to decide what type of data goes where. Next, you have unstructured data, which is less organized with no clear path for searching or filtering. Imagine taking your favorite book, separating each page, then placing the individual pages into a box and shaking it. All the information is still there, but there is no structure in how it is saved. You may have come across the term blobs. Blob is an acronym that stands for binary large objects, and it simply stores unstructured data. As the name suggests, it stores large unstructured objects. Examples of unstructured data that a company may keep include streaming data from the security cameras or sensor output data from on-premises devices. Imagine that Sam Scoops has installed several devices on the premises. Devices might include live monitoring of electricity consumption, freezer temperature, and door activity, like how often it is opened and how many people come in. It could also include alarm system outputs. Blob storage would be ideal for this unstructured output. Later, Sam may revisit this information, apply some analytics, and extract some business insights to help reduce cost or improve sales. So, how do blobs work? Blobs are stored in containers. This is like a filing system where each container has a general name like pictures or movies. Inside this container, you can store as many blobs as required. Of course, the blobs themselves will be unstructured, and further filtering or searching methods are needed to find a specific item inside the blob. Previously, you learned about solid-state drives and hard disk drives as options for local storage. Azure Managed Disks offers users these options in a cloud-based form. Recall that this means you can keep a standard secondary source of information accessible through the web. You can have the benefits of versatile storage by integrating Azure Managed Disks into your business setup. You will not require hardware that is often quite costly to acquire and run, and users can specify the size of their disk according to their needs. To access managed disks, a virtual machine is required. You will learn about these in greater detail later. For now, you should know that they are software computers that work as if you are running a CPU, RAM, or connection. This video covered cloud storage with a focus on Microsoft Azure. You learned about the 3 Azure data services, which are Azure Files, Blob Storage, and Managed Disks. Sam now knows that the questions to ask when choosing an approach include: what is the company's business need? What type of information is being stored, and how is the information to be accessed? Knowing the answers can help determine which type of storage is the best fit for Sam's Scoops. You might be aware that a common practice amongst many successful businesses is to analyze data in order to generate new insights that can help guide business decisions. For Sam's Scoops, this might mean observing deeper than the pure sales numbers for a particular flavor of ice cream. For example, is the flavor more popular with a certain age group, or maybe it sells better on a specific day of the week? It can be difficult to discern this information from raw data. So in this video, you'll become familiar with data processing techniques that make it easier to transform numbers into actionable ideas. Data processing can be a useful method for extracting valuable information from customer data. To demonstrate how it might be used productively, let's walk through the steps that Sam can follow to gain insights for Sam's Scoops. Specifically, you'll find out how she can gather data, store it, and perform data analysis, visualization, and integration. Sam's Scoops might want to collect various types of data, such as sales data like the quantity of each flavor sold, customer data including such details as name, age, gender, and email address, and marketing data, which would tell which advertising campaigns were the most effective or which social media accounts experienced the most engagement. Some of this data, such as sales numbers, will be gathered naturally while running the business, but other information would require a dedicated data collection method. For example, to learn more about customer opinions, Sam might provide a form that asks customers about their age, favorite ice cream flavor, and how frequently they visit the shop. After collecting this data, Sam would need to store it somewhere. Previously, you learned about data lakes for holding unstructured data and data warehouses for storing more organized data. Depending on her goals, Sam could use either of these or a combination of storage methods. For example, she might use a relational database to store the sales and customer data and a data warehouse to store the marketing data. Sam would need to consider data architecture, such as how the data is structured and organized, to ensure that it is easily accessible and secure. To make use of this data, Sam would need to analyze it. Data analysis is a broad field with many methods and tools available. But let's say that Sam's primary goal is to find a relationship between ice cream sales and different points of the year. In this case, she might use predictive analytics to forecast which flavors would be the most popular during different seasons. Another possibility is to use statistical analysis to identify trends in sales and customer behavior. There are also machine learning processes that can be applied to data depending on the data type and the desired outcome. Machine learning is a particularly notable technique that you'll learn more about later. Even if data analysis provides enough information for Sam and her team to change their business strategy, data visualization would be an important technique for Sam's Scoops to use to communicate insights from their data to different stakeholders. They might use charts and graphs to display sales trends over time, or map customer locations to identify areas where they should target their marketing efforts. In addition, being able to display data in a clear fashion can help integrate the data for some insights. Finally, Sam's Scoops would need to integrate their data from different sources to gain a comprehensive view of their business. They might need to process all of the data, transform it to a common format, and load it into a central repository for analysis. To understand the value of this practice, consider the ways in which Sam's Scoops sells ice cream. In addition to sales from the shop, they also deliver to customers who place orders online or by phone. The data from these channels is likely quite different, and they would need to combine it in a way that expresses the bigger picture. Integrating data might mean taking observations from these different settings and using them to gain a greater understanding of customers' general ice cream wants. In this video, you learned about some common data processing techniques and discovered how Sam could use them to learn things about her business that are not apparent from the numbers alone. Data processing is an important part of any business, and by collecting, storing and analysing data, Sam Scoops can gain valuable insights and make informed decisions about their operations and marketing strategies. So far, you've become aware of some techniques for processing data that can generate meaningful insights to help drive business decisions. But did you know that this doesn't have to be a fully manual task? It is possible to automate much of the analysis by training a computer to do it instead, through a process called machine learning. Machine learning is a part of artificial intelligence that helps machines learn from data and make predictions. It's a way of teaching a computer to recognize patterns and make decisions based on what it has learned. For example, let's say that Sam's goal is to more accurately predict customer behaviors when it comes to purchases at Sam Scoops. She could accomplish this by analyzing sales data from previous years and identifying trends. But doing this manually could become costly and time-consuming as the business grows. Fortunately, there are many great machine learning tools that could help Sam do this. It's like having a brilliant assistant who can help you analyze data and make predictions. In this video, you'll explore the basics of machine learning and how it can help businesses like Sam Scoops make better decisions. You'll also find that it's not just useful for ice cream shops. Machine learning can also be used in cybersecurity to help detect and prevent cyber attacks. Now, let's go through the steps that Sam can take to use machine learning for predicting customer demand in certain conditions. To do this, Sam would first need to gather historical sales data from Sam Scoops. Specifically, she'll want the sales figures for different flavors of ice cream on working days, weekends and public holidays. Also, she needs to record the outdoor temperature from when certain ice cream was purchased. After collecting this data, Sam needs to check if it has any errors or missing values. She can use special tools to look at the data and find any mistakes like missing or strange numbers that don't fit the rest of the data. Once the data is clean, Sam can choose a good place to build a model. This is called pre-processing, which is a very important step in building a good machine learning model. If the data has too many errors or mistakes, the model will make poor predictions. Next, Sam can teach the computer how to find patterns in the sales data using a set of rules called algorithms. This helps the computer to better understand the data. Finally, she can test the computer's prediction skills by giving it some data it has never seen before to see if it can make accurate predictions. To summarize, the key steps are gathering data, pre-processing the data to ensure that it is clean, training the computer on the data using algorithms, and testing the computer's predictive abilities. It might be simple to predict certain things without the help of machine learning. For example, Sam could figure out which ice cream flavors are the most popular in a given season just by observing past sales figures. However, machine learning can go further and identify patterns in the data that are not readily apparent. For example, a trained computer might discover that on really hot days, customers buy ice cream in plastic boats because cones melt too quickly. Or perhaps it finds that customers buy fewer scoops on colder days. Establishing these patterns is important because when Sam feeds more data to the learning model later, such as the weather forecast, it can make suggestions about the quantities on the order form. In the previous example, you observed how machine learning can be trained on data to gain insights for making more sound business decisions. But, as mentioned earlier, it can be applied to cybersecurity as well. So, how would that work? Imagine you are a security specialist and you want to prevent unauthorized entry into a system. You might set up a rule that too many failed login attempts will lock an account for a while. Or you might note the location and prevent access if it is different from what is expected. Machine learning can be used to determine which rules to apply. Much like how Sam can match ice cream flavors with the weather, you can train machine learning models using data from previous hacks. The model will then identify the patterns which can be used to make rules. In this video, you've discovered that machine learning is a powerful tool that can help businesses like Sam Scoops make better decisions and improve their operations. By training a learning model with real data, Sam can predict customer demand more accurately and place orders more efficiently. Furthermore, machine learning can be used to create stronger cybersecurity solutions. As machine learning continues to evolve and become more accessible, it will play an increasingly important role in businesses across various industries. Perhaps you're aware that cybercrime is a growing concern, but do you know how it affects businesses? Let's become familiar with some of the statistics. One prevalent method of attack is spear phishing, which is the practice of sending fraudulent emails that appear to be from trusted sources. The email typically contains a link or attachment that, when opened, installs malware or has some other harmful effect. According to a 2022 report, more than 21,000 incidents were reported in the United States, resulting in billions in losses. How do such attacks happen and what is being done about it? To get a better understanding, let's first become familiar with Riley's experience. Riley works as a UI/UX designer for a company that creates custom payroll solutions. Although digital design is his calling, Riley is well versed in IT in general. He is aware of the types of cyber threats that exist and follows practices to keep himself safe. One day, while using his company-issued laptop, Riley checks his inbox and comes across an email from his supervisor. He opens it and finds a message explaining that a potential client has submitted a unique request, and Riley is asked to go over the details in an attached document. Nothing seems out of the ordinary, so Riley clicks on the link. However, rather than downloading the document, he gets stuck on a loading animation. Moments later, he hears chatter in the office. Several colleagues complain that they can't open any files in the company's shared cloud storage. That's when it dawns on Riley that he has been fooled and the security of the company's network has been compromised. Many people can identify the telltale signs of a fraudulent email. For example, you might become suspicious when you receive a message from someone you know, but you notice that the email address is different from the one they usually use. However, cyber criminals are getting smarter when it comes to crafting emails that make even the smallest details appear authentic, making any signs almost undetectable. So how can businesses protect themselves from these sophisticated threats? One answer might lie with artificial intelligence. Machine learning engineers have created smart solutions that can catch the small giveaway details that people often miss. This leads to more capable cybersecurity systems that demand less human vigilance. By analysing a sender's emails, a machine can learn to distinguish the tiny differences that separate a fake email from the real thing. It examines the source of the sender, formatting, and other details that differ from the norm, and then assigns the email to the appropriate category. Such solutions can then detect and stop malicious emails before they ever reach the recipient. The result? Businesses can rest easy knowing that they've lowered the risk of an email attack. Now, let's rewind Riley's story and find out how a solution like this can change the outcome. Riley opens his inbox, and the first thing he sees is a notification about a suspicious email that is supposedly from his supervisor. This message has been quarantined separately from his inbox and awaits his action. He asks his supervisor about it directly, and she confirms that the message didn't come from her. Crisis averted. Riley responds by reporting the email to the company IT security team. No harm has been done, and he continues about his day. Thanks to advances in artificial intelligence and machine learning, there are now new ways to combat the evolving methods of cybercriminals and to keep businesses and their employees safe. Well done on completing business systems applications. You should now have a stronger foundation of knowledge relating to various technology solutions that businesses use to facilitate tasks and enhance productivity. Before you continue, let's recap the key concepts that you learned about. First, you became familiar with business software applications and the roles they serve. You should now know that there is software to address needs in various parts of a company's operations, ranging from inventory management to financial analysis. Business applications can be line of business solutions or enterprise resource planning software. Line of business applications serve a specific business need, while enterprise resource planning relates to integrating several processes to ensure that they all work together in a coherent way. Recall that business software can consist of single applications, or it can be comprised of several applications bundled together, which typically address common needs. You became aware of Microsoft's most widely used products and services for enterprises, including Word, Excel, PowerPoint, and the Microsoft Dynamics 365 collection of customer relationship management tools. You then applied all this knowledge in an exercise that had you identify 3 business needs for SAM scoops and then explain which business software applications could be used to fulfill those needs. Afterward, you observed some examples that illustrate how some of these tools can be put to use in the workplace. Specifically, you witnessed how SAM might use PowerPoint to style a menu for the shop, Word for generating invoice forms, and Excel for recording the company's budget. Next, you discovered the role that email plays in business communication. You observed how mail advanced in parallel with technology, shifting from physical delivery to electronic means and creating a more connected world in the process. You should now know how email moves in the client-server model, in which a series of specialized protocols are used to get a message from the sender to email servers and finally to the recipient. You then explored 3 popular email clients, namely Microsoft Outlook, Google Gmail, and Mozilla Thunderbird. You found that they share some common functionality, such as the ability to store contacts and organize emails by category. You then moved on to learning about spam, a type of unwanted mail that can range from annoying advertisements to attempted attacks using dangerous links or attachments. Fortunately, as you discovered, modern email providers include security features for reporting and filtering out spam messages to help keep you safe. Some of the more dangerous types of spam that you might recall include phishing emails, which try to trick people into revealing sensitive information, spoofing emails, which are fraudulent messages that claim to be from a well-known source and prompt users to perform actions like sending payments, and spear phishing emails, which are targeted messages that appear to be from someone you know but may contain malware or other harmful elements. Finally, you were introduced to the means that businesses use for storing and handling vast amounts of customer data and why they would want to do so. You found that data can come in structured or unstructured forms and is typically stored in a large repository. Depending on the needs and intent of the business, raw data can be stored in a data lake or processed data can be placed in a data warehouse. You should now be aware that businesses value customer data because it can be analyzed to generate new insights. While this can be done manually on a small scale, for larger volumes, companies may turn to machine learning. You learned that the core steps for training a machine learning model include gathering data, pre-processing it for accuracy, using it to train the model, and testing the model's ability to make predictions. With adequate data, machines can detect patterns and make informed guesses about the outcome of any additional inputs. You also received a preview into how machine learning can be used to create more intelligent cybersecurity solutions. Specifically, you explored how, when given examples of fraudulent credit card transactions, a learning model can eventually distinguish between real and fake payment based on factors such as the frequency of activity, the location from where the payment is made, and the amount spent. By finishing business systems applications, you now have a better concept of how businesses use software, email, and data storage and processing solutions to assist in daily operations and to enable smarter planning. Nicely done.